Happy Tuesday, everyone. It's good to have you. Welcome back to Mastermind Academy. For many of you, it might be your very first Mastermind Academy. So welcome. I'm really excited tonight. We are starting, what are we starting? We're starting deCoded tonight. I get my days a little mixed up. I just got home from work, just got started. But yeah, tonight's deCoded. So we're gonna learn how to do some coding. It's good to see everybody. What's up, Penguin Airlines? You are first today. Congratulations. Good job for being on time. What's up, Grenade 32? Tonight's topic is basically just an introduction to the course. It's really a syllabus day, but we're also going to dive into the basics of computer science and how a computer works a little bit, and also some introductory things about coding languages, data types, stuff like that. Real basic stuff. 1 second, let me mess with my little balance board here. I am standing up now. Got a fancy standing desk because you got to be amazing and special. And I have a little balance board here to keep my back and stuff from getting tired while I'm standing. I do like to stand when I'm teaching, so you'll see me moving around a bit. It is purely because I'm balancing on a wobbly surface right now. What's up, L4? How you doing today? What's up, Fatima? How are you doing? Isu Boy, what's up, Dorothy? Good to see you again. Burning JC, people coming back. I love it. What's up, MLL? How are you doing tonight? What's that? Farium? I tried it. Let me know if it's something different. How are you doing tonight? What's up, Agki? How you doing? Welcome. What's up, Rockatus? Welcome. Let's see. Oh yeah, the Twitch ADA schedule is where it's at. From Chattanooga, Tennessee. That's pretty dope. I actually don't think I've seen anyone say they're from Chattanooga so far, so welcome. Good to have you. Where is everyone from? We always like to do a little roll call at the beginning of these to find out where people are tuning in from. We get people from 6 of the 7 continents. One day we'll get a polar bear or something tuning in from Antarctica, but I'd love to know where you're tuning in from. I am on the East Coast of the United States. I'm in Baltimore, Maryland. We're about 45 minutes from Washington, DC, the District of Columbia. But yeah, I got the Uplift V2 standing desk. It was, I couldn't tell the difference between all of them, to be honest, but I like it. Excuse me. But I like it a lot. I definitely like it a lot. I'm a fan of standing desks for sure. Just to, for me, the movement isn't so much like for my health. I didn't get it for my health or anything like that. It keeps me focused. When I get tired of sitting and, I start to tune out and it's hard for me to focus, then I'll stand. And that'll kind of change my scenery a little bit. And then I'll move back when I'm too tired to stand. So that's why I did it. From Barcelona, how are you doing? We had a couple people from Spain or España yesterday, so dope. Clearfield, Utah, welcome from Utah. Guadalajara, Mexico, Happy New Year to you as well. Hello from India, what's up, Prop? How are you doing today? San Jose, Costa Rica, had a couple of Costa Ricans here yesterday. I appreciate you coming through. Yeah, I'm definitely, I'm a big fan of the standing desk, and it's a lot larger. So I actually have a lot more things on the desk, even though I downsized my monitors. But yeah, Liverpool, I love it. Oh yes, Visa Dan, I think you were here yesterday. I appreciate it. Good to see you again. Laylar, okay, got it. I figured it out this time, even though you gave it right to me. I figured it out from Seattle, Washington. Good to see you. Strong Arkansas. I like it. Mexico, OKC, Brooklyn. I love it. Berkeley, California. Philly, welcome, man. We're neighbors. We're basically neighbors out there in Philly. Calgary, Canada. East Oakland, like I was telling people last time, we drove up to New York just to get cheesecake and then stopped in Philly for the cheese steaks. We went to Martin's, maybe it was Martin's. I don't know what it was called, but it wasn't, let's just say it wasn't not in the hood, to be honest, but it was worth it. We were there for a long time, but it was definitely worth it. I appreciate it. What's up, Second Bill Cycle? Good to see you. I'm seeing a lot of people that I'm, my friends. I love it. What's up, Lot Sir? How you doing tonight? Detroit, I love it. Pretty dope, everybody. But hello from wherever you're tuning in from. I'm glad you're here. I'm glad you were able to find us and you're looking to start the new year off right, and investing in yourself and learning a little bit about programming, because that's what we're gonna do tonight. Tonight, we are starting deCoded. This is the Apprentice level of deCoded, the introductory deCoded course. So this is a journey into software engineering and computer science, and it is an 8-week journey and we'll be taking it together. Yesterday, we did start Pipelines, which was a journey into software delivery, automation, and infrastructure. That's for you DevOps and SRE focused people. If you're interested in picking up some additional skills to this, we also have a cloud bootcamp starting on Friday called Horizons, a journey into cloud computing with AWS. So you have a lot of options here, but it's good to have you. It is really, really good to have you. Yeah, hole in the wall. I mean, it was not, I wouldn't call it a hole in the wall, but it was near where a lot of hole in the walls were, to be honest. But it was good. It definitely was good. I definitely enjoyed it. We would go back. I grabbed the McLeod Golang course. Dope. I'm telling you, it is, like I said, he's not everyone's cup of tea, but the course has a lot of information, and I really, really did enjoy it. So what is tonight? The first night of any type of course, always gonna be pretty chill. Tonight is mostly syllabus stuff, making sure we're in all the places that we need to be, all the channels, the discords and stuff. So make sure you know how to use Twitch a little bit. But tonight we're also going to dive into some of the basics of programming. We are going to learn about that tonight. We are going to get set up with a text editor. I'm just going to, for people who've never done anything like that before, we'll get set up. I'm also going to do a quick remote development environment setup as well, to kind of help some people out in case you want to follow along exactly as I'm doing things. But I'll explain a little bit more about that when we do get there. We'll set up a little remote development environment with Visual Studio Code, so that we can, you'll have the exact same environment that I have. But you don't need to do that. You are free to use the tools which speak to you in your heart. But yeah. If anyone is not in the Google Classroom and wants to fully participate in this course, go ahead and hit _register. So !register. The exclamation points are how you can submit commands to Twitch, and it will, we have a little bot here that will give you some information and some answers. You can also do !Discord. If you want to link to the Discord, there is a space in Discord for this deCoded class and the questions and the resources that you want to check out there. Or you can hit !commands to get all of the available commands. That'll take you to an external site that'll give you all the commands that we have set up. But yeah, I got some slides, so if you're in the Google Classroom already, we got some slides that should have been released at 7 p.m. And let's ensure that happened, because a lot of times I fat finger the time in which these things are supposed to release. So let's go ahead and let's just make sure really quick that we are good to go here. And yes, I'm using Bing. We talked about this a little bit yesterday. I am using Bing, but it's fine. Don't sweat it, okay? I'm also using a new account on this Surface, so I'm not signed into anything. So I'll be getting signed into everything right now. I'm also a bad typist. You'll learn about that later. So you'll see me mess up a whole lot. Oh man. I know that you can't see my password, so I'm not sweating it right now. Let me just get logged in really quick. You see that? That is a very long password. I'll do my best not to leak it. I will leak a password probably 2 or 3 times throughout our stream. I'm very good at resetting my passwords. So, I'm very good at it, and I will do my best not to do that this time. So let's just make sure everything was released first. Pipelines Apprentice. No, this is not Pipelines. This is deCoded. Got to get my days correct. And classwork. Perfect. It looks like everything that we needed to be released is all released. So slides. Go ahead and click on the slides. Hopefully they are available. Let me make sure that I've made them available to anyone who has the link. Anyone with the link. All right, so if you weren't in it, now you should be in it. You might have been in it before, but these are the slides that we are going to go over tonight. Yes, so good question. You will be getting, if you complete all the things we're going to go over a little bit, if you complete everything, you will be getting a certificate for the course. You'll be getting a certificate of completion that you can use to show. As we go on, we are going to make this more and more legitimate every time we do it, so that people start taking this very seriously, because we do some serious things here. We do learn a lot, and you should get credit for the things you do here. You should be able to get credit for the things that you do here. We're also partnering. I'm also working on partnering with companies to make sure that we have access to roles and things that are designed for people getting into tech, whatever level that we're at. We teach a bunch of different levels of these courses, and so we're partnering with companies to make sure that you all have opportunities when you are going through these things and you're picking up these skills, or at least a way to talk to someone to find out a way for you to get into these roles. So let's hop into it. This is for basic programming. And so I don't want to call it, well, this is for the basics of computer science and software engineering. It's a little bit of a hybrid. We'll learn a fair amount of computer science concepts, and we're gonna be learning how to code. So it's not pure computer science where you are learning the theory of things. You're gonna be learning the practical hands-on approaches to things, but we're gonna be learning a lot of the base level things that a lot of people skip, especially when you're self-taught. A lot of people skip some of the base level things that matter the most. So we'll be going over a lot of that stuff. So we'll go over all the stuff we're gonna go over in the course right now. So what is this? Why are we here? What are we doing? So about Mastermind Academy, this is Mastermind Academy, welcome. This is intended to be an engineer's one-stop shop for training and job opportunities. Hence why I let you know that we are going to be introducing job opportunities to you all. What's up, Alt F4? How are you doing? I am back. I came back yesterday, but I am back. As soon as I get through this slide, I will give you the best shout out because I do want to give people other resources, especially in this class when we're doing a lot of coding and software engineering. There are a lot of people building really cool stuff live right here on Twitch that you can learn a ton from. The Alt F4 stream is one of them. I'll give them a shout out so you can easily click on it and give them a follow in a second. But Mastermind Academy is a platform. This is the platform designed to deliver live interactive technical skills training to anyone, no matter where they are, at no cost. So the goal is to be able to share this information with anyone and everyone who wants to have it, and ultimately to transition the cost of training from the learner to the company. So we're trying to partner with a lot of companies to make sure we can make this bigger and better and introduce more topics and things, because this stuff is hard to learn, and it's better when we're learning it together. Yes, you can go do a self-paced course. I encourage you to do so. Even along with this, I encourage you to use as many resources as possible to make sure you get the knowledge that you need. But I think it's more fun when we do it all together, when you can get your questions answered immediately and all that good jazz. But let me go ahead and give a shout out here to the Alt F4 stream. The Alt F4 stream is an extremely knowledgeable fellow and friend who does a lot of cool stuff here on Twitch. I really highly do recommend that you give him a follow. He's always building some cool stuff. Does a lot of Go, does all kinds of stuff. I've learned a ton from his channel. We also play some games on here. We play some Among Us every now and then. You know, we don't only work, we have a lot of fun as well. So definitely give him a follow for sure. Definitely good stuff there. I spend more time than you all know watching others code here on Twitch. I learn a lot from the people who are on here. So that is what it is. It is completely free. That's what I want to say going into this slide. It's completely free. There is no obligation. You do not have to do anything. You don't have to pay anything. It doesn't matter. You can participate 100% in the bootcamp, but there are ways to contribute if you'd like to support. All of this will go away once all these companies start to supplement this, because, you know, they need us. They need these engineers, you know, as a part of their companies. We need to build a tech pipeline. You know, there's a reason why it's hard to hire. There's a reason why it's hard to retain technical talent. Our skills are very high in demand. And so once they start paying out, so if you have a company who wants to support something like this, you know, let them know. You know, we just, you know, I got mouths to feed, okay? And by mouths, I mean mine and my wife's and our soon to come child. See, now I got your heartstrings. I just tugged your heartstrings a little bit, but now I'm joking. Zero obligation, but there are ways to support. You can contribute to the channel. You can contribute to these efforts at academy.mastermind.io/contribute if you'd like. Yeah, and you get some things if you contribute $15 or $30 and above. You will get the ultimate sticker pack. You can see here that for nothing you get just about everything, but what you don't get is sweet swag like stickers, shirts, masks, and socks. Right now there are no masks and socks. There are no masks. There are socks. $15 you will get a sweet sticker pack, ultimate mastermind sticker pack from me. And if you donate $30 or contribute $30, you'll get stickers and you'll get some sweet socks And again, this is, you know, this is to help build the community here, and so that we can do more and more of these classes. Or if you have Amazon Prime, Twitch is an Amazon company. This is your first time on Twitch, or you've never spent any time here. It is an Amazon company. If you have Amazon Prime, they give you a free subscription per month. A subscription is something you can do to a channel and to support the channel, as well as remove ads from your videos, as well as gain access to sweet emotes like these sweet custom me emotes. And you don't even know who I am yet because I haven't introduced myself, but you can get some sweet emotes like that if you are interested. Or if you have $5 to burn, they cost $5, they go up to like $25. And you can do the monthly. Twitch gives you one each month. You can click that link, or you can go to that URL if you want to do it, or if you want to click on any of the panels and things below, feel free. Again, no requirement to do so, just these are some ways to support. And don't forget, I do have a little baby on the way. First one, actually pretty excited about it. Gonna be pretty cool. But cool, that's all there is for that. Now it is time for you to meet me, the man who's been talking to you for at least 20 minutes, or well, 15 minutes. Okay, I've been talking to you for 15 minutes and you don't really know who I am. What's up, Thug Muffin? How are you doing? It is good to see you. Just warms my heart to see all these amazing people. Yes, Anthony Wright's code is cool. I want to share all of the resources pretty soon, but me, time to meet me. I am a former technical lead and DevOps engineer. Former being as in I left my role, my latest role, in October of this year. Not this year, because it is now 2021. Happy New Year to everyone out there. In 2020, to run this company Mastermind full time. There are other aspects to Mastermind that aren't just the academy, but the academy will always be here. It will always be free to you. This is the thing that I love most about the company. But so I've been running that since then. I went through a digital services incubator called Hutch. One day I'll share more information about all of that in case anyone else is interested. But it was pretty dope. And yeah, now I'm out on my own, doing pretty well, to be honest. You know, making things happen. It is very, very exciting. But I am a 90s baby. That matters, because I'll joke about a lot of things. I'll say a lot of things. I have Pokemon, you know, Pokemon poster, original 150, 151, maybe. I don't know how many are on that poster. That's important, you know, that's important to me, just to give you some insight into some of the things that I do, some of the things that I say. I will also let you know that, back to the DevOps engineer thing, I'm a DevOps engineer who comes from an ops background, not from a dev background. Generally, you're going to get one of the two. Don't really know if that matters to anyone. Just wanted to share. I love ops stuff. I love cloud computing. I love all systems things. But yeah, I love cars and motorsports. I told everyone yesterday, like 86% of the reason why I decided to start my own company instead of staying in the tech industry, purely as an employee in the tech industry, was because I want to have enough money to be able to run my own little race team, grab my truck and a trailer and my race car and be able to, you know, ride around and race and learn how to drive really, really well and fast and compete in some, you know, amateur race series. I have no desire to be a pro or anything like that, but it is a very expensive hobby and I would like to participate. Currently, I drive a Focus RS that I got as kind of my do everything car. I do have a truck now so that I can tow that to the track. One day I will get rid of that and get something a little more track worthy. It's very track worthy, but there are some shortfalls on the track, but I'm also not that amazing of a driver yet. So it'll work for me for now. But yeah, that's what I want. I love cars. I love motorsports. Don't really care about fancy cars. I care about car performance. I have a keyboard addiction for sure. I've built a few. I've bought many more, but I'm an absolute garbage typist. I'm a terrible typist. I'm awful. You'll see me mess up a lot. I will look down at my keyboard pretty often. That's just how it is, y'all. You know, I've gotten better. I'm getting better. People here on Twitch have encouraged me to be better. Like the Primogen, which I will share, another great resource, especially when we're talking about software engineering and programming. He actually works at Netflix. I will share his information as well, because I think it is a phenomenal channel for people to learn from. I learn a lot. And yes, the Moonlander Club, I would love to order a Moonlander, except that I just ordered not one, but 2 GMMK Pros from Glorious PC Gaming Race, because they got me. I have most of their stuff and I need one for here and one for the office. And to be honest with you, I can't afford 2 Moonlanders. One Moonlander costs what both of those keyboards cost together. So that is that's where we're at with that. Let's see. The little crying emoji is by far my favorite emoji. I use it all the time. I wish I could run through my phone and do a count of how many times I've used this emoji in comparison to other things. I love it. It's my favorite. I don't know why. That's now you know more about me. Pancakes versus waffles. Pancakes always win. The only thing that beats these both is French toast. French toast is phenomenal, particularly the kind that is on brioche, brioche bread or brioche buns. Is what I like the most, but pancakes are better than waffles. Don't at me, don't argue with me. You're wrong, I'm right. And we can now move on from here. And just so you know, I was once top 50 on the East Coast in competitive Yu-Gi-Oh! The trading card game tournaments. I was young. I was a young buck, maybe 14 or 15, and I was amazing going against people who were much older than me. Just want to give props to my father who had no idea what I was doing, but was driving me around the United States, well, the East Coast. We went to Philly a couple times. We battled, and he saw me win a couple of great ones of riveting challenges. But that was pretty dope. I was there for like a week, and then I got wrecked at the next event a lot. I did not win a game at the next event, but your boy was good for a little while. Pretty strategic. Didn't have the best cards, but a lot of off the wall strategies I was able to come up with. Because sometimes you just got a knack for things, and Yu-Gi-Oh was my knack. I never learned how to play Pokemon, the trading card game, but I promise you that I would have been the best, the very best, like no one ever was, for sure, guaranteed. Yeah, that's what it would have been. But for sure, that was me. The crying emoji, it can be used for anything. It is very, very versatile for sure. Also, Dorothy, thank you so much for gifting your sub to the noob programmer. Please, new programmer, please. I'd like you to now grovel at the feet of Dorothy and say thank you for everything that you've done for me with this gifted sub. I no longer need to be staring at ads, and now I have sweet access to dope emojis. That's what it is. Who's gonna win the Heisman? I'm gonna win the Heisman. I don't know. I haven't actually been following college football very much this year, which I should be following it more because my brother is a college football coach. He's a running backs coach at Maryland, and I usually follow pretty closely. But this year I've been pretty busy, and I have not been following, so I don't know. I definitely don't know. Nowadays, everybody is former. Definitely former. But I love it. Yes, please pass it forward. Definitely do that. But thank you very much. All right. So now that you know a little bit more about me, let's move on because we actually have a fair amount to do tonight. And we went overtime yesterday, and I want to make sure that we don't go overtime tonight. Generally, we'll talk about it a little later, but generally these are going to be scheduled. They're scheduled on the there is a Google Calendar. I think if you type in !! calendar, you can follow it if you want to know when everything is. These are scheduled on the calendar for, I think, 2.5 hours. They're not 2.5 hours usually. There are going to be days where it might be, but most days we're going to try to hit the 2-hour mark. Some days will be even shorter at around 1.5 hours. But we'll take our time. We'll get through things. We'll have a good time. We'll try to get as many questions answered as possible. So, hopefully you can stick around. But if not, there are ways for you to catch up and to follow, even if you are not able to. I don't know what's going on with my mic, but it is not sturdy right now. Every time I touch it, it moves. But here we go. So the very first thing we're going to talk about is expectations and requirements. We'll go over the syllabus. We'll talk about programming, what it is and how a computer works, just to get on the same page. A lot of us are coming into this at very, very different levels. And today is really going to be a day to kind of set the foundation so that we all kind of have a baseline knowledge of things. And then we can move forward from there. We are going to talk about text editors and runtimes and get those installed. And then we're going to do a little remote development environment setup again, just so in case you want to follow along exactly how I do things, you can do so. So yes, Doc Jones. Yeah, today is the first day of deCoded, the journey into software engineering and computer science. Yesterday, we started pipelines, a journey into software delivery, automation, and infrastructure. That's DevOps and SRE stuff. And on Friday, we are starting our cloud computing horizons, a journey into cloud computing with AWS. So, yep, come on through. So expectations and requirements. What you should expect? I read that wrong and I was like, man, my English is pretty terrible. A lot of times it is, but I think we're okay there. These are the primary expectations. Really, it's to gain a strong foundation in programming and computer science concepts. Notice the last word in there, and I should bold this. Notice that it says concepts. Yes, we are absolutely going to be coding a ton in this course. We're going to be learning how to code. We're going to be writing a lot of code. But what I want you to focus on throughout the entirety of this course is the concepts. Not necessarily the syntax. Don't worry about where the semicolons go. Yes, you will get those things. Those things will they'll come to you. You'll cement them in your memory, but the concepts are what we're focused on here. And I'll really try to harp on that because I tried to learn how to code a bunch of times before I was able to use code successfully to do anything. And it's because I was trying to learn a language rather than understanding what to do with that language. I didn't really understand what you could do with code. And once you understand what you can do with code, it becomes much easier to use code to solve real world problems. And that's the second point, to learn how to use code to solve problems. So not only are we going to learn it, but we're going to learn how to use it to actually solve things. And then I want you to have an understanding of how software is created. This one is super interesting. And I threw this on here because a lot of times people will learn how to code and then they'll get to the end of it and they'll be like, oh yeah, I want to work on a project. And they have no idea kind of the scope of things you can do with code and how you can take these little pieces of code and make a real digital product out of it. And so I want you to have an understanding of how to do that as well. You will not leave this bootcamp being a pro coder, okay? You won't leave 8 weeks, 2 times a week. You will not be a pro coder. But you will be well on your way. You will be able to have a lot of really good concepts under your belt. You have touched a lot of things. But the good news is that this is not the only coding course. There are 3 levels to all of the journeys that we do. So this is the apprentice level, the beginner level, the introduction. At the beginning of the year, you know, everyone's got a lot of energy. We're getting you in, we're getting you comfortable. And then we will run a journeyman level, which will take it up a notch. And then we will run a master level, which will take it up even higher. And after that, you will be. You will be a pro for sure. But, you know, take your time. We'll talk more about how to approach this stuff, but take your time. So what should you expect? Secondary. This one is huge and this should really be a primary one, but an understanding of how to approach learning new concepts and technologies. Okay. This is very, 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 very important here. This is all the tech industry is. This is all, whether or not you're coding, whether or not you're cloud computing, whether or not you're AI, machine learning, whatever you want to do, you need to be able to approach learning new concepts and technologies, and you need to learn how you do that best. And so hopefully this course is going to help you learn that as well. That's why I'm going to give you resources from all kinds of different places. I'll give you articles, I'll give you podcasts, I'll give you all kinds of things. I want you to explore it all. I want you to combine them and see what ways you can get the best outcomes when you are diving into these things. The next thing is I want you to be at peace being confused or lost. We will all be confused and lost at many points in this, especially when you are starting your journey. And I'm going to be honest with you, as a professional, we are confused and lost every single day, most days. I'm confused and lost, and you get comfortable with that. You become at peace with that because you understand how to use your tools. You understand the rules of the things that you're doing. You've experienced enough things. You've touched enough things to kind of know what to expect. You kind of know what direction to go, and you know you can use those, you can lean into those things to be able to figure it out. But it's okay to be confused and lost. You will be very often. People who have been in the industry for a while, they're not just, you know, just sitting there like, yeah, just doing the thing, I know how to do everything. That's not true at all. So make sure, hopefully you can become okay with that. The realization that no one knows it all, that's another one. It's very easy to feel like everyone knows so much and knows everything, and you have so far to go. Yes, you might have a long way to go to get to someone else's level, but that doesn't mean you don't know a lot. And no one, like I said, knows it all. There's plenty that this person doesn't know, and it's okay not to know everything. You're not supposed to know everything. Just pick up what you can as you're, you know, just learn, continuously learn, pick up new things, and you'll be able to eventually put all those things together to be great. I want you to have a strong belief that tech is for you and that you can thrive in it. It's very easy for something like coding programming to discourage you and to make you feel like you don't have the talent for this, you're not smart enough for this. Well, I will tell you right now, this is not true. Like I told you, I had to try to learn how to code 4 or 5 times before I was successful at being able to do things on a job. I had a sysadmin background, so that's what I did, and I stayed away from coding, to be honest, for a long time. And when I got back into it, it started to click after the 5th or 6th time. So don't sweat it if you get into it. I thought this wasn't meant for me, but the last job I was at, I was a technical lead for an application team. I was not a DevOps tech. I was not a DevOps lead. I was a technical lead and architect for an application team. I helped build a lot of cool things. Really exciting. Did a lot of cool stuff. Built a lot of software, and I'm pretty excited about that. And that's how I know. That's how I know coding. The tech industries for anyone who wants it. There's a spot for you. There's a lot of different avenues into tech. But yeah, I want you to believe that you can do it. I want you to believe that it's for you. Then I wanted you to know how to use memes effectively. Really, really important. I love memes. They're the best thing ever, because now you can show people how you really feel. So I'll be using memes for everything, also as a device to help you kind of memorize some of the things that are here. But yeah, these are things I want you to get out of this. It's very open. It's there's we have a structured learning plan, but what you want to get out of this is going to be how much you put into it. I'm really excited to see all the great things that come out of the collaboration and things that happen. I know last time we had a group of people who started up a little study group session a couple times a week, and they would hop into Discord and hop into the voice call, and they would do some cool things like that. I can assist in setting things up like that if you want to, but make some friends. Plan on sticking around for a while, because I hope to see some things too. All right. I hope to see some active engagement in the chat and Discord. This is, again, not for me. This is for you. The more you put into it, the more you get out of it. And so you can do this by asking questions. Make sure you are asking questions. No question is a dumb question. Okay, I'm serious about that. If anyone asks a question and you know the answer, feel free to answer that question. So I want people to answer questions, ask questions, answer questions. Don't be mean to anyone, please. I will stop that immediately. I promise you, other people have the same questions that you have, no matter how terrible you think this question is. Ask it so you can get the proper answer, so that you can understand. Whether you don't have to ask it live, you can ask it in the Discord. You can find someone that you trust and ask them directly. However you want to do it, get answers to your question, write things down, make sure you know what's going on. And then even if you're not sure you know the answer to something, but you think you do, try answering it. Try giving feedback to someone when they ask something. You may say, hey, I just read about this yesterday and I think this is the answer. But I just learned about it, and let people know that. And I think that's completely okay to do, but try to also assist your fellow learners. You're all on this journey together. I'm on this journey with you. I'm also learning a bunch of things as well. We're all on this learning journey together. Help each other out. Be kind to each other. Be kind to yourselves, for sure. Do not be hard on yourself. Some days you're gonna feel great. Some days you're not gonna feel great. Some days we'll get to a slide where I give you a little pep talk, but be kind to yourself. Be kind to others. You'll get through it for sure. Definitely feel comfortable being confused for sure. All right, let's see. It looks like it's okay for me, but definitely try refreshing for sure. I'm monitoring it on my end and it looks okay, but I'll give people a chance. How do you refresh? Hit that F5 or just hit the little refresh the entire browser page, for sure. Hopefully it'll work. Looks good. Like I said, I'm watching the metrics. Looks good on my end. Hopefully we're okay. Cool. No longer experiencing lag. Excellent. Emptying your cup to start learning. There we go. As a tech person, your main job is to create solutions to your business problems. Facts, for sure. Most of my time is spent learning what and how to implement something. That is 100% true. Actually implementing it takes a little time after I've learned how. That is 100% the perfect answer. That is exactly what you're going to be doing. You spend much more time trying to figure out what the problem is and the solution to the problem and how to implement it. The actual implementation is actually pretty easy in comparison. All right, so those are things that I hope to see. Affirmations of progress as well. Let me know how you're doing. I'd love to see, like, if you pick up something new, if you're studying something, let me know. If you're on Twitter, whatever, wherever you're at, let me know, because I'm learning things too. Makes me feel good. We're all working together to get smarter. So yeah, there we go. So here are the requirements. This is not a weed out course intended to only be for the elite who are going to go to Stanford to work at Facebook. We are here with the only intention is to learn, is to learn these important things that can honestly help you shape the world. I don't say that lightly. Tech has the power to change the world. If you learn to wield it, you have the power to change the world. You have the power to change your own lives. You have the power to change your entire lineages if you pick up these skills. And so that's the goal. The goal is simply that. So not crazy strenuous. The next 2 levels of the course will be more strenuous than this one, but there will be 16 live sessions. You do not have to attend every single one. I encourage you to. I have no idea if you attend every single one, so that's why you don't have to. But there are 16, just letting you know that that's where they are. There are 7 quizzes. There are 7 graded quizzes, and there are 3 exams. They are not the end all be all. Don't sweat it. What these are to just gauge kind of where you're at the time. Feel free to, make sure you write down the things that you got wrong. It'll let you know, it'll give you some feedback on the things that you got wrong. Write it down, go look it up afterwards, watch a YouTube video, completely okay. Like, write it down. Make sure you are just to give yourself a bar to measure against. That's all. You have the opportunity to retake these things. You have opportunities to pass no matter what. So don't be too afraid of them, but do your best on them. And then you have 12 GitHub assignments. GitHub Classroom is pretty dope. It allows for me to create auto-graded assignments for you all. And so you will be submitting code to GitHub. You'll learn how to do all that. If you have no idea what that is, don't sweat it, but you will be trying to code problems. Now, these 12 assignments, again, are for practice. They're not here to make you feel like you're not good at things. They're just to flex your memory muscles and to flex your thought muscles, not memory muscles. I don't really want you to memorize anything for real. But to flex your thought muscles and to allow you to practice, to get hands-on with this stuff, give you an opportunity to implement some dope things. So don't sweat it at all. Also, BeginBot is here. And BeginBot, also another excellent resource to watch and to learn from here on Twitch. Let me give you a shout out. I am not typing into where I need to type into. There we go. Again, there are a lot of great resources here. So definitely head over and follow BeginBot, because there's so many people to learn from here, especially for this course in particular. There's a lot of people to learn from. How much knowledge is needed to apply for an entry-level job after the course? Can't wait to get into the industry. That's a great question. So this course will give you all of the foundational tools to be able to get a job, but it probably won't give you quite enough implementation of those foundational skills to apply for a job. Some of you will be fine, but many of you will need to do some more practice and get a little more hands-on. Programming is coding and programming is interesting in that learning to do the thing isn't necessarily all that difficult. Yeah, there's some confusing pieces to it, but learning to write the thing is not really the hard part. It's learning how to solve problems, and this will teach some of that thinking, but there's some more development that you'll probably have to do. That's what the second level of the course is. Now, you should be doing a lot along with this as well, to kind of help you out. And so depending on how much you do outside of this, you may be ready, but 8 weeks isn't really a whole lot of time. So I just want to make sure that I'm very honest with you. I don't think you'll be able to walk into an interview for a programming job after taking this course, but I think you'll be close. I think you'll be able to go in and not feel like you know nothing. I think you'll be able to answer some good questions, and kind of understand at least what's being talked about. But I think it'll take a little more practice to be able to solve some cool problems. It's J Phil, thank you so much. Welcome as well to tonight. This is another person you can go follow for some cool coding stuff. He plays a lot of games and stuff too, but you can give It's J Phil's a follow for sure. I appreciate that. What's up, Proximate 10? Good to have you. What's up, Richard Pavafort? Welcome to the channel. A bunch of other people as well. I appreciate it. All right. Let's see. You can become a pretty powerful quickly in the world of DevOps. Yeah, I mean, you know, you can become pretty powerful pretty quickly anywhere you want to become powerful if you put in the time and the work. But I do want you to put in a little more time than what's happening here. So we're going to spend between 3 and 6 hours together per week. I want you to spend at least an additional 4 outside of this, covering the supplied resources, trying to do the problems that we have from GitHub and things like that. Yeah, at least 4 hours outside of here is what I would recommend. I understand everyone doesn't have that much time. That's okay. I think for you to get the most out of it, you should be spending at least 4 hours outside of this. And then I want you to attend 2 Saturday office hours. This is not necessarily for you to ask a bunch of questions. If you have them, for sure attend. There will be 4 office hours on Saturdays, Saturday mornings, Eastern time. But I'll be on for a little while. I encourage you to attend 2 of them because people will be asking questions that you didn't know you had. And I think you can get a lot of knowledge out of there. But yeah, you know, it's there we go. Those are the requirements. Like I said, we have ways to verify you know, the things are done. When the things are done, so these GitHub assignments, they will be graded. They will not count towards the completion requirements for this. The quizzes and the exams will. I'll give you the exact number when I release the very first a quiz that's going to be at the end of this week. But you'll pass. If you want to pass this, you will pass it. You'll have the opportunity to pass all of them. It's okay. Don't sweat it at all. Like I said, the other sessions will be a little bit more difficult just because we do want to bring some validity to the higher level courses. We're gonna bring, there's a lot of validity in all of them, but one thing people have expressed is really wanting to have something to show for finishing these things. So yeah, that's what we're gonna be doing. All right, syllabus overview. What time is it? Cool. Syllabus overview. Courses.mastermind.io or academy.mastermind.io. Courses will be going away pretty soon, to be honest. But let's go take a look really quick to see what we're going to be learning over the next 8 weeks together. All right, so this is the Apprentice course, and what we'll be learning. I want to be clear, I'm not calling anyone a baby. You know, this is just a really good emoji to say, hey, you're starting this thing out. You're in your infant stage of learning here. So that's what little baby's for. And then you grow up a little bit when you get to the journeyman level course. Yes, this is the intro presentation in the deCoded course on GitHub. On Google Classroom. This is, but this is just on the website on courses.mastermind.io. All right, so week 1, we are going to be doing a lot in this week. We're going to be, we're halfway through today. We're going to be learning about programming, how computers work. We'll get some stuff installed today, and we'll get a remote development environment set up. Next time, we'll also dive deeper into the editor of choice, my recommended editor of choice. We'll talk a little bit more about that. And then we'll dive into, actually, this is mixed up a bit. I'm not sure this is the latest version. This is mixed up a bit. We'll actually be learning a lot of this stuff today. It's kind of switched around. You'll be learning about compiled versus interpreted and static versus dynamic today. We'll be learning some Linux next time. This is supposed to say a little bit Linux because a base level of Linux command line skills is going to be needed to kind of move through this. Don't sweat it. It's going to be fine. I promise you it's going to be fine. So we're going to be doing that next time, but we're going to be learning a little bit about Git later this week as well. So that'll be on Thursday. Then we'll be diving into displaying output and strings and making sure people can see things, and we can get our words and phrases out of there, and learning a little bit about iteration. Then we'll be moving on to how to work with numbers and operators, arithmetic operators, conditional, so we can start to add. Week 3 is where we'll start adding some logic to our code. Then we'll get into loops. Loops are pretty dope. We'll do a lot with loops. They're very fun. I think loops are where you're like, when you get into loops, you're gonna feel like, okay, I'm doing it. I'm definitely doing it. You get to do some cool stuff. This is also where it's gonna get the most confusing though. Loops are where it's gonna start to throw you for a loop, You like that? You see what I did there? Hold on, let me exit Slack really quick because it is ding dinging in my ear. All right, there we go. All right, then we'll get into functions and reusable code and scope. So these are a little deeper, and then we'll dive deeper into Git because Git is pretty important. Then we'll talk about errors and error handling. Then we'll get into algorithms and start problem solving. Then we'll learn a little bit about object-oriented programming and finish off with some more algorithms and projects. Okay, that is what we will be doing in this first part of the course. I think that the apprentice level is in here. So if you ever want to see what's after this, or the journeyman level is in here, there are some stuff here. And really, this is just more of the implementation. This is going to switch up a little bit for the next run, but yeah, it's there. Oh yeah, we're definitely going to talk about Dunning-Kruger for sure. We're definitely going to talk about Dunning-Kruger like we did last night. Right now, okay? Here is your prep talk. Also, Zero Fate, thank you so much for the tier 1 sub. I appreciate you. Appreciate you being a part of the family for 3 entire months. That's amazing. I do appreciate it. It's good to have you. Thanks, fam. All right, so pep talk. Here's your pep talk. I'm gonna give you all some real pep talks. Once we get into things, you don't really need. I'm gonna save my energy for the real pep talks a little bit later. But you do need a little bit of, every week you're gonna need some pep talking to get you moving forward. All you gotta do, tell everyone to just get through one more session. Just get through one more day, one more session, one more problem. That's it. And but this is a pep talk. You will get discouraged. You will get confused. You will want to quit, but you can do it. All of these things are true. It can be discouraging, absolutely, especially when we're talking about something that this is your brain, this is your thinking. It's tiresome. This isn't hard physical labor, but it is labor. You're doing a lot of thinking. You get confused, and you want to quit. But I promise you can do it. Keep moving forward. This is no different than anything else that you're trying to get better at in life. We all know that if you want to become, you want to get in shape, we know what to do. We know that if you go to the gym, even if you're eating terribly, you may not lose weight, but we know that if you go to the gym and you get on the treadmill, every day, and you lift those weights every day, you will get stronger. You will get more in shape. Your heart will get stronger. Your cardiovascular system will get stronger. We know that'll happen. We know it's hard. We know it's difficult to do, but we know if we go consistently, we will become better. We know that we'll get better. This is the same way. We've got to work these brain muscles. We've got to see it. We've got to immerse ourselves in it, and then it becomes normal. We're really going to try to treat this like when if you want to learn Spanish and you just cut on Telemundo, you don't know what's going on, but eventually you start to pick up on some things. You hear more and more, and you start to pick up on some more things. Before you know it, you may not really know exactly what those words mean, but you understand the situation. You understand what's happening. That works here just as well. We'll be learning some words specifically. We'll be learning things specifically. But the more and more you immerse yourself in it, the more and more you hear the things, the more and more you read about things, and you see the word here, and then you see it again in a week, and and then now someone talks about it later, you'll start to make connections in your brain. You'll start to understand these things, and it'll make it pretty easy. Also, learning is not linear. This is very important. Learning isn't linear. So if we're going through some things and you don't understand something, or you're having trouble picking something up, and you're trying and you can't get it, a lot of people will stop and get stuck on that one thing, and then they will quit. This is okay. It's okay not to learn that thing. Yes, sometimes not picking up a concept, not picking up something will make it tougher to learn the next thing that's in line, but learning's not linear. You can miss those things and then pick up the thing over here, and then pick up the thing over here, and then pick up the thing down here, and then, oh, this thing down here will help me understand the concept of the thing that I missed earlier. And now I can take that, and now I have this piece. But it's like putting together a puzzle. And so, it's nice, puzzle's nice if you can start from, the top left corner and do the border and then start to fill in. That's great. That would be phenomenal, but it's not always like that. You can still put together the puzzle if you don't do it in order. So don't sweat it. Take your time. Again, be kind to yourself. I'm so serious about you being able to do it. This will be a little bit of a mental fight. Okay, you will today will probably feel great to you, and the next time will probably feel pretty good. And when you get to that first assignment, you'll try to do it, and you'll say, "Oh man, I don't understand any of that," and then you won't feel like coming anymore, and that's fine. That's fine. But I always say, give it one more class. Whenever you decide to quit, Give it one more session, give it one more problem, and then see if you still want to quit after that. I you know, always one more. This is just like anything else in life. It's tough, but you know, at the end of the day, you can learn this stuff while sitting on your couch, eating a bowl of cereal, having a good time. So you know, there are harder things. So do your best to stick with it. I think we're gonna have a good time here. And yeah, I mean, hopefully that's a little baby pep talk. Not really even a pep talk, but I will give you guys some epic pep talks one day with the get ready. You need to do it. You are strong. I'll give you one of those one day. All right, I will definitely give you one of those. So when you need it though, you don't need it quite yet. Also, Mr. Don Brown, welcome to the channel. Thank you so much for the raid. Everyone from Mr. Don Brown's channel, welcome to deCoded, where we are diving into our computer science and coding careers. It is good to have you here. I do appreciate it. Definitely do appreciate it. All right, so now that the pep talk is done, here we go. Let's get into it. Programming. I don't even know how computers work. How am I going to program? So this is just to give you a little introduction into programming. We'll learn a little bit about computer program specifics and how computers work and all that other stuff. So the first thing we're going to dive into is, in fact, the hardware. All right. Hardware is really important. Hardware is the actual physical items that make up the computer. Okay. And so the first thing that we're going to talk about here is the CPU. All right, compute. The CPU is the brain of the computer. It contains all the circuitry needed to process input, store data, and output results. The CPU is constantly following instructions of the computer program that tell it which data to process and how to process it. Without a CPU, we could not run programs on a computer. So this is essentially this is the brain of the computer. This is the major piece of the computer that is calculating things for you. It takes instructions and it does those instructions and it moves very fast. This thing, this is an image of one right here, a very powerful one actually. But when you're talking about computers, maybe your own personal computer, if your computer says Core i3, Core i5, Core i7, maybe a Ryzen, I don't know, 7 something, whatever. These are the brains of the computer, and they work by processing electrical signals. A bunch of electrical signals get passed through them. They work on clock speeds, gigahertz, and so you might see something that says, hey, this processor is 2.8 gigahertz, runs at 2.8 gigahertz. This 1 gigahertz is 1 billion instructions per second. Okay, it's a lot. 1 billion instructions per second. And so the more gigahertz you have, the more, it may be gigahertz, I don't know, because it's gigawatts, I don't know. But you know, the higher the clock speed, the more processing it can do. Different processors can process more things, and the more powerful your processor is, the more things that you can do. Okay, so it's the brain of the computer. It does all of the logic. That's all you kind of need to know now about it. We'll dive deeper into all these things. This is a very light introduction. Don't want to pass too much to you at once. We'll talk about threads and cores and all that other stuff later in the course. So the next piece of computer hardware you need to know about is random access memory, or RAM. All right, you probably been to the Best Buy and they say, how much RAM do you need? And you say, bro, I have no idea. You work here. You are supposed to tell me what I need. Okay, but random access memory is pretty important. It is used for the temporary storage of data, and I really want you to understand this because RAM is very important, or memory is very important in terms of computer programming, and it's going to cover a lot of concepts that we talk about. So this part is pretty important. Whoops. But it's only used for the temporary storage of data. All right. It temporarily stores things. RAM is actually really important because everything that's processed by the CPU, that brain of the computer, it's all passed there from memory. Memory is what passes things directly to and from the CPU. So memory is pretty important, works in conjunction with the CPU. The only important thing you need to remember right now is that it's for temporary storage of data, and that data is ephemeral or volatile. So I wanted to throw these two words in here because they're talked about a lot in this fashion. They coincide, and you'll hear this pretty often. So it's ephemeral. It's not designed to be around for long. Temporary storage. Volatile means that that the data actually goes away if the power is cut from the RAM. No more data remains there. It doesn't stick if power is cut. So if you cut off your computer, stuff's always running into RAM on your computer right now, on your laptop, on your phone. When power is cut, all that data goes away. And when the computer starts back up, it starts all over again, and it starts transferring data to and from RAM. It is not designed to hold data for long periods of time. That is RAM, or random access memory. We'll talk about the random accessing later as well. Hard drive. Hard drive is another storage device on your computer. Unlike the RAM, unlike the random access memory, this stores your data even after the machine is turned off. It is not volatile, okay? A hard drive is the storage unit for the machine. I think you all are probably pretty familiar with a hard drive. How much, how many pictures, how many illegally pirated videos can I hold on here? That's what you care about. And so that's what it is. It's for the persistent storage of files and data. It's permanent storage, okay? Well, semi-permanent because it can fail, but that is in fact what that is. So RAM is for temporary storage, and it moves very quickly. It's very fast. It is extremely fast, much faster than hard drives. And hard drives are for the persistent storage of data. Now you might hear people say SSDs. These are solid state drives. These are permanent storage devices as well. They just work a little differently. They're flash storage instead of magnetic storage devices. So, but they're still hard drives on the computer. Well, they're still for persistent storage. They're not hard drives, but persistent storage for sure. Just cool. Thank you so much for the Twitch tier 1 sub. 6 months. That's impressive. You've been around for a while. I appreciate the love. I appreciate the support. It is good to have you for sure. All right. So there are many more pieces of hardware in a computer, but we don't need to talk about those things. There's video cards. There's all kinds of other stuff. That doesn't matter. The three that I want you to know and to look up after we're done here and, learn a little bit more about is the CPU, the RAM, and the hard drive. And actually go into the CPU a little bit. Maybe this might help some of you if you're in the Mac, if you're in the Apple community and you've been hearing all of this craziness about the new Apple M1 silicone, new M1 Apple chips. They're talking about the CPU. Apple built their own computer brains. Before, they used to use Intel chips. Intel, big company. There's the other companies. There's a few other companies who make CPUs. AMD is another big player in the computer game, the personal computer game. But Apple made their own silicon, and it's of a completely different architecture than the current existing ones. So it's a new brain, and it's a new brain that processes things differently than the old brains. And so that's why it's such a big deal. We all learned how to work with these brains. Now we're getting a brand new brain coming from the Apple ecosystem. And so that's what all that talk is about. It's about the CPU of the computer. All right, the central processing unit. Okay, so that's the hardware, just a little bit of hardware. Now let's talk about some software. All right, software. Hardware is the tangible, touchable, physical pieces that make up and run your computer. Software is the applications and code that runs that computer. So what is computer science? This all falls underneath software. So what is computer science? Computer science is the study of computers and computational systems. Unlike electrical and computer engineers, computer scientists deal mostly with software, so we're talking about now, and software systems made up of software. This includes their theory, design, development, and application. Now, we're not going to dive into a bunch of theory here. We will dive into more theory as we go up the ladder in the courses. This is going to be mostly practical things. But we are going to spend some time in the computer science realm to make sure you get that. What's up, Ethan? Thank you so much for the tier 1 sub, 3 months. Appreciate you. Yes, these do, I forgot, that is something I forgot. These do all go up on YouTube 24 hours after they air. And it has to be 24 hours just because, well, it probably doesn't have to be, but there's a clause as a Twitch affiliate or partner or whatever, that I can't put it anywhere for 24 hours. It'll go up on YouTube after 24 hours. It'll be more like 23 hours because it'll likely go up after the next day's course. You can also watch it on Twitch. You can watch it on Twitch for 14 days. So feel free to come on back and watch it through Twitch, but it will be up on the YouTube channel. So feel free. It's going to go into a playlist. One thing we are changing, if you're someone who's been following along with older courses on there, to clean up the YouTube channel, because we are going to start releasing weekly YouTube videos, either this week or next week. I can't remember when the first one is scheduled to drop. It'll be on Thursdays. But we're gonna clean it up a little bit. So there will only be one version of a course on YouTube at a time. So the apprentice level of deCoded, there will only be one playlist from a time. So every time we run it again, we will replace the old videos with the new ones. So just, if you're following along with an older one and you start to see videos being replaced, that is what's happening. Gifted Lane, thank you so much for the cheer, the 100 bits. I appreciate you. Thank you so much. All right, so that's what computer science is. We're talking about software systems, and we're learning about the theory behind them, the way that you design them, the way that you develop them, and their application. But what is programming? Like, what the heck is programming really? And so all programming is to provide a computer or other machine with coded instructions for the automatic performance of a task. This came directly from Google. This is not a statement from Google. This is what you get when you Google what is programming. And so it's a pretty simple answer, and I really do like it, because this makes programming much less complicated, at least in my mind, when I first heard it. And all it is instructions for your computer to do something automatically. So it's literally a set of instructions. That's literally what it is, for your computer to do something automatically, so that you don't have to intervene and do things manually. That's all it is. Okay. Pretty simple answer. All right. That's all we're going to be doing. We're learning how to give the computer instructions. That's all we're learning how to do. The intermediate class will not start until like March. So we'll run all 8 weeks of all 3 of these courses, and then there will be a couple weeks off, and then we will start the intermediate courses. There will be something else in between called excursions, which are shorter, like 2 to 3 week items that dive into specific topics, things like Git, things like Docker, things like Kubernetes, things like Linux, where we dive into a specific topic so that we can focus on it. But yeah, yep, they're definitely February and March. So yeah, all we're going to be doing is learning how to tell a computer how to do stuff automatically. That's it. But how in the world do we give a computer instructions? And the way that we do that is with a programming language, okay? And so computers actually only understand one thing. They do not understand language in which we know it. Computers actually only understand something called binary. And so binary, I think it's in here somewhere, but I may have saved that for another thing. I did leave you some resources, but binary, the word bi means two. It means two. Binary is a reference to 2 different states. A lot of people like to reference this as ones and zeros. This is how people always talk about computers. Oh, ones and zeros, that's all it is. It's really 2 states. It's really on and off, or, electrical current flowing through something or not flowing through it, gate open or closed. 2 different states. And this is how a computer it's how it computes things. It's how it makes decisions. It passes electricity through transistors and through these gates, and it turns them on or off, and it can transfer information that way through binary data. But that would be terrible for us to work with. That would be awful for humans to work with. So we can interact with computers through programming languages, and these programming languages ultimately get broken down into data that the machine can read, that the central CPU, the central processing unit, can process. But yeah, we need to be able to write something that's really good, that we can understand. So how does a computer understand what we write? And so first, it takes something called source code. Okay. And we'll talk about which of these things are. There's source code, there's compilation or interpretation, there's bytecode, and then there's machine code. These are kind of the levels of understanding for a computer, and we are going to talk about these things. And a lot of these things are the things that a lot of people miss, again, when they are self-taught. You'll do these things, but you'll not really understand what's happening, and it helps a lot to understand what really is going on during these things. So, what in the world is source code? Source code. It's the human readable code that you write. So this is what you actually write right here. The human readable code. Like, you may not know what any of this is over here, and it may be hard for you to see, but the word print is right here. That's an English word. You can see that. You can see the number 50 right here. You can see the word for and in and range right here. Okay. So, like, you know, these are things that your eyes and your brain can pick up on and can understand. Okay. Like I said, you may not be able to decipher what it all means now, because there are a lot of symbols, and like the symbols are things you've seen too, the parentheses, and there are quotes and stuff like that. But at the end of the day, there are words here. You can read this stuff. Okay. This is source code, is the human readable code that you are going to be writing. You are going to be learning to write source code. That is what programming is. All right. Old R. Yeah, you know, old R code. It looks very Python-esque, you know? All right, so then the next level is a compiler. Okay, so we need to be able to take the code that was written, the source code that you write, and ultimately we need to be able to get it into a state that the machine can read. So a compiler is a complicated piece of software or a piece of technology that translate the source code that you write into machine code, which is binary or bytecode, but it translates it into code that the machine can read. Okay, so it's like Google Translate. It takes everything, you know, from what's on the left, and it turns it into what's on the right, even though that is obviously not what a machine can read, but that is essentially what's happening. I actually think that this translated through Google Translator. Not really sure. But yeah. So that's what a compiler does. All a compiler do, when you hear about compilers and compiled languages, basically it just means that after you write the code, it has a translator that's going to translate it directly down into machine code or bytecode. You might say, okay, what's bytecode? When we talk about binary, we know that binary is those ones and zeros that the computer can understand. What about bytecode? What is bytecode? Well, actually, that's the next. So let's go to bytecode first. Well, bytecode is an intermediate format. Okay, intermediate format for the source code gets compiled into. The bytecode is optimized to be interpreted or run by a virtual machine. This part, I'm bringing this up to you now. I'm not fully expecting you to understand what this means yet, but I want to introduce you to it now so that you hear about it, so that you can start to chew on it a little bit, and then as we get deeper, I think you'll start to understand it a little bit more. But so this does not directly translate down into machine code. It translates it down into something that's closer to machine code usually, but this new code, this bytecode, is optimized to run on a virtual machine, on another thing that is going to be able to interpret and understand your code and ultimately translate it down into the system. So that's what it is. A common use of this is Java. If you've ever heard of Java, Java runs on something called the JVM. It runs on something called the Java Virtual Machine. So when you write Java code and you run it through the translator or through the compiler, instead of making it something that the machine can read directly, it makes it something that the JVM can read. And the JVM is running on a computer, and the JVM knows how to return and understand that code. Okay, so that's what bytecode is. And then this is another, so this gets pretty interesting. We're not going to go too deep into the intricacies of this, but the last thing we're going to talk about tonight is, well, at least for this part, are interpreters. Okay, so for compiled language, for language that uses what we know as a compiler, when you write the code, before it can be run, generally it must be translated into something that the machine can run. Interpreters instead interpret your code line by line. They instead interpret your code line by line. Every line of instructions is passed to the interpreter, and the interpreter then you can almost say compiles, but it then interprets what that code is supposed to do and moves it into machine code. It moves it into ones and zeros. Okay. Now you might say, oh great, like that sounds cool, like that sounds really dope. We'll talk about the pros and the cons of this. So compiled languages, you need to compile the entire program before you can run it. Generally, these are general statements. There are going to be exceptions to these rules. Right now, we're going to say that a compiled language must be translated completely before you can run it. Okay. Even for ones that are going to translate to bytecode, we must translate everything into bytecode and then pass that bytecode to the virtual machine that's going to run it. An interpreter, on the other hand, can kind of run this code real time, and we can write the code and immediately kick it off, and the interpreter will, instead of pre-compiling, it'll run down the code line by line, and it'll try to understand what to do and interpret that into something that the machine can read. And we will highlight this. I'll show you. You'll understand exactly what this means within the next week. You'll understand exactly what this means and the difference. And yeah, and then you have just-in-time compilers. 100% just-in-time compilers are kind of like this. We're gonna dive into just-in-time compilers probably next week. But yes, just-in-time compilers are they're kind of a hybrid of this. Again, I don't want to get too deep into it right now because there's some specifics of these things that I think it helps if you build on them a little bit. But they're compilers that basically take the code and compile these things right before they're run as you kind of get to them. So we'll talk about that a little bit more. All right. And so again, the machine code is binary. Those two states, I want to be clear about that. Again, everyone will tell you ones and zeros. Yes, ones and zeros are just a representation of the two states, one being on, zero being off. But it's not ones and zeros. It is essentially two states, and those two states are actually electricity or no electricity, to be honest, open or closed. All right, so you've got these two different types of programs. We got a lot of different languages. We'll go over the different languages that exist, but we have compiled and we have interpreted, and basically they all fall into those categories. What are the benefits of compiled versus interpreted? So compiled languages are very efficient at runtime. I'll break down runtime in a second, which means they are very fast. Okay, they're very fast, especially in comparison. I'll show you a chart in a little bit. But what is runtime? Runtime is literally the time in which the code runs. It's literally when when that application is executed, that is the runtime. So that means when this code is executed, excuse me, it will be very fast. Why will it be very fast? Because it's efficient. It's already been translated. Okay, it's already been completely translated, which means the computer understands what to do with it, and it's much faster at runtime. Okay. Also, generally, silly errors are caught at compile time. So if you have an error in your logic or an error in your, well, not logic, but if you have an error in your code, a syntax error, there's all kinds of other errors. We'll talk about errors. If you have an error, it will actually catch it during compile time. How can it catch it during compile time? Well, it's doing translations. It's doing a bunch of translations. It's allocating space and memory. It's doing all kinds of stuff. And when it gets to a point in which it can't do the action that's expressed in the code, it will fail. And so this gives you some insight on, early on whether or not your code is going to work or not. So that's, it can be pretty helpful. Due to its efficiency, compiled languages tend to be less of a strain on computer resources. So usually, if you have a computer that doesn't have many resources, those resources are usable resources from the hardware, like RAM. You have a limited amount of RAM. You have a limited amount of hard drive space, a limited amount of things that your CPU can process. And every time you do something with the CPU, every time you save something in the RAM, that means that there is now less resources for you to use to do any type of actions, any type of actions at all. And so they tend to be less of a strain on a computer because they are compiled they're compiled beforehand, and they're more efficient. And so notice the word is tend. And so, there's a lot of arguments that can be made there. And then the last thing, this is not always true, but static typing is generally a trait of compiled languages. Not always true. There are other languages like Elixir that is compiled but not but it's dynamically typed. We're going to talk about typing tonight as well. But the typing is static in a lot of languages, and this is helpful for finding bugs and for discovering bugs and for seeing bugs before things are happening, and for understanding what's going on in your code a little bit. When you're starting, you're gonna hate compiled languages. We're gonna be doing mostly Go. About 65% of what we're gonna be doing is Golang. Well, it's Go, it's not Golang, but whatever. And about 35% Python. You will hate Go probably, especially once you see Python. You will probably really dislike Go. Go is great. I think you will learn to like it eventually, but at first you'll probably hate it because there are a lot more rules here. And so we're gonna talk about that. But interpreted languages, some of the benefits are that changes to code can be made and tested very quickly. Why? Because every time you make a change to your code, you don't need to recompile the code. Every time you make a change to compiled languages, you must recompile all the code to be able to run the application. Because interpreted languages can kind of just be run and kind of interpreted line by line, you can make a change and immediately run it. And so usually you can make changes faster and test them more quickly. That's a benefit. Generally, debugging is easier, and that's a little bit for the same reason. And it's a very general statement. Debugging can be easier because you can quickly make a change and put things in and figure things out. And generally these are dynamically typed as well. And again, that's not going to make any sense until we get to the part where we are talking about types. Keep in mind this word dynamic versus static in terms of types is very important. And again, you will likely like interpreted languages more right up front. They have more direct feedback, and there's a lot of instant gratification to interpreted languages. But I think ultimately most people end up at least being able to appreciate compiled languages because of the benefits that they provide as well. So very light introduction. There is something in your Google Classroom for more on that. This is an introduction. You might not understand anything we're talking about yet, but you're hearing the words. You're hearing compiled, you're hearing interpreted, you're hearing some of these other things. Dive into it a little bit deeper. We will dive into it deeper, and it'll make more sense once we are running code. The reason why we are using two languages and not one is because one is compiled and statically typed, and one is interpreted and dynamically typed, and they provide you different levels of knowledge. There are different rules for both of them. If we were to only focus on an interpreted language like Python, you would miss out on learning a lot of the important rules that come in compiled languages. This is why if you go to any computer science program, they are very likely going to be teaching you a compiled language first. Usually that language is Java or C#. And so it's because there are a lot of rules here. There are a lot more concepts to understand, and it is much easier, in my opinion, to move from a compiled language to an interpreted language. No, not always, but usually it is. So that's why we're gonna be learning both of those things. I learned in my networking class that there are two ways to represent a bit. You can do the absence or presence of voltage, or you can do the transition. One would be interpreted if the change in voltage, and zero would be if there's no change. I thought this was really cool when I learned it. Yes, 100%. I'm actually really glad that in your networking class, they talk about voltage and they talk about the electricity that's flowing through, because it isn't ones and zeros. It is just a way of representing them. I like that a whole lot. If you run your interpreted code more than once, will the interpreter overwrite the bytecode each time, or is there any benefit to saving the first run bytecode from the interpreter? That is a good question. All right, so that's an interesting question. And I don't want to end up going too deep down this rabbit hole. There can be a benefit. I think that in 98% of the cases there will be no benefit because computers are so fast nowadays. So I don't think there's a tangible benefit to 98 or 99% of the cases. So just simply rerun it and it'll be fine. All right. Yep. C and C++ a lot in the comp sci courses. Yes. So let me tell you this right now. If we go into Go and you're like, ugh, I don't like this, but like you're learning it, and then I show you some C, or C++, you'll be like, okay, I love Go. Go is amazing. It's the best. So we'll talk about that deeper now. So data types, we talked about static typing and dynamic typing right here. Typing has nothing to do with hands on keyboard. It has nothing to do with you physically typing. It is talking about data types. Okay, there are different types of data that can be expressed with your code. These are just some of the basic types. This is not at all an exhaustive list. We will dive deeper into this, but just like Pokemon, you all know that I'm a Pokemon lover. In Pokemon, you have a bunch of different types. You have rock type Pokemon, and you have bug type Pokemon, and you have electric type Pokemon, and flying and grass, all different types of Pokemon. Our data types are kind of similar to this. Some of them work well together, some of them do not. Strings is an important data type. These are lists of characters, so think words and phrases. We've got things like numbers, so we got integers. Okay, these are whole numbers, and we've got booleans, which are true false values. So anything that's true false is a boolean value, and anything that is not a whole number has a decimal, and decimal numbers are called floats. This is a different data type than an integer. And when you're doing math and stuff, you have to account for things like this. And then there are other data types that are collections. So arrays and slices, these are collections of data. Okay, and so this is not for you. We're gonna dive into this stuff later. This is just to give you a little insight on what's to come. But when we're talking about dynamic and static typing, dynamic and static mean that the types of data. So if a piece of data that in your code, if it starts off as a string, for a dynamic language, it means that, hey, if later on in the code I want to change it to a Boolean value, or I want to change it to a float, change it to a decimal later on in my code, I can do that. So if it started out as a word or a phrase, and eventually in my code I want to change it to a number, and then maybe to a Boolean value, I can do that. The type is dynamic. I can change it at will. Static typing is the opposite. It means that, hey, types can't change. Sometimes this is called strict typing as well. It means, hey, once this piece of data once you tell me that it's a string, this piece of data must be a string. You can convert it. There are ways to convert it into something else, but you can't just set it to something new. You can't just say, hey, this piece of data was a string, now I want it to be a true false value. You can't just do that. It's very strict about these things, and the type of data matters more throughout the code. And so that automatically introduces more rules, and we'll see that real time very soon. Like right now, this is where it gets in and it gets a little bit tough. So this is a real time test. It might not be real time because this is a brand new installation of Windows, but it's okay. I might log into my server and I should have this stuff installed. So dynamic typing. Types are evaluated at runtime. So when the code is run, this is when the data types are evaluated. Therefore, type errors present themselves at runtime. So if you do have a type error, because you can have type errors even in dynamically typed languages, you won't know until the code runs. The interpreter may infer type in order for the code to run properly. So when the types are dynamic and you do something weird with it, your interpreter, remember, it's interpreting what it believes you're writing. It will do its best to interpret what you mean, and sometimes it'll make that thing okay and it'll make it work. So in the coding language JavaScript, very popular language of the web, if you do a number 5, so this first 5, you don't know this yet, it's an integer, so it's a number. And if you add that to another 5, but this 5 has quotes around it. Quotes are the pretty much universal sign that this thing is a string. A string is a word or a phrase. It's a character, or it's a character. It's a list of characters. So this is in the code. This is a list of characters, so words and phrases, and this is a number. And when you add them together, if you add them together in JavaScript, you will get 55. Okay, you will actually get 2 5s together. All right. Because it does some type inferencing. It says, hey, I think I know what you're going to try to do here. You did this thing. I believe this is what you're hoping to do with it, and it will give you this 55. Very interesting. Okay, you might have thought it was going to give you 10. Nope, it'll give you 55. The string 55. Let's be very clear. It'll give you the string 55. Okay. Now, static typing. Static typing, on the other hand, it evaluates these types at compile time. So when it does the translations, Compiling is when the translations happen. And so it will attempt to figure out the types at compile time. And then so that means that if there are any errors, it will present them to you then before the application is run, which can be a really good thing because you don't want any errors when the application is actually being used. Types are explicit, no type inferencing for the most part. This is generally no type inferencing. So this will not try to figure out what you mean. It'll say, hey, you got to tell me exactly what you mean. You must tell me exactly what's going on, what I should expect. And this is why, again, more rules here, more rules. You know, you got to be explicit about what's going on, but it means that generally you're gonna have less errors generally. So if you try to do this in Go or any compiled language for that matter, or pretty much, if you try to add a 5, the 5 integer, the 5 number, and the 5 string, with the word and the phrase 5, it will give you this error. It'll say, hey, I can't convert 5, which is type string, to type integer. I can't do that. I don't know how to do that. And also, I can't do these because there are mismatched types. These types don't match. I can't use them together. One is a string, one is an integer. These are 2 different data types. I cannot do anything with them. Okay. And so already we can see an interesting thing, like errors don't look good right now. This looks like, you know, it's got a bunch of extra stuff here, some numbers, some slashes and stuff. Errors can be scary, but they are actually pretty helpful. And so yeah, you can't do this in Golang. There are rules here for this, but in something like JavaScript, you can. I think you can do it in Python. I don't know what'll happen in Python. We'll check in a second. So Go again is compiled. So you must compile it first, kinda, and then it is static. So types matter, but Python, on the other hand, is interpreted and dynamic. So you'll get the best of both worlds here. All right. So let's see. Compile does all the work. Just fix the bugs, and it yells at you about, yes, compiled languages, they yell at you about a lot of stuff. That is why I like them. I make a lot of mistakes. And being someone who has worked in ops for so long, you know, I'm used to the break fix world. And I'm comfortable with errors. Like, I'm not weirded out by errors at all. They don't scare me. I'm not afraid to see red on the screen. You know, that's information. That's good information that tells you where to look. And so, you know, I probably rely on errors a little more than I should. I'm really good at deciphering them. And so, you know, run it, gives us a problem. Cool. You told me exactly what's wrong. Let me fix that thing. You're going to lead me right to the answer. And so that's, you know, I really do like that. I find that to be pretty beneficial for me, at least. All right. And so this is a nice little diagram that I like that shows the differences in some coding languages. And it shows this scale over to the left is fast and fun for humans. So, you know, fast and fun for humans to write. Like, how fast can you get something cool out there? Is it fun to write? And so, you know, the higher you go up the scale, the more fun and fast it is for humans to write. So we got things up here like Ruby, like Python, Perl. I don't know why Perl is there. And we got JavaScript, okay? Then we have this axis over here on the right. So as long as you go as you're going up to the right, the faster and faster these coding languages are for computers. They're fast and efficient for computers. So you get all the way up here, and C is very fast for computers. C++, very fast for computers. Java, very fast for computers. You know, not as fast as these. Go, very fast for computers. But C is not fun to write. Look at that. C, if you go up this scale, look how low it is on the fun and fast list. It's not fun to write. C++, also not fun to write. Okay, it's very interesting. But, you know, you get up here to Java, and Java is kind of, you know, almost at the sweet spot, and it's fast, and it's kind of fun. You know, in comparison to some other things, it's kind of fun. But look where Go is. Go is pretty high. It's above halfway point on both the fast and fun for humans, and it's also very fast for computers. It is a systems language that was written by Google. It was born out of Google, but it's both fast and fun for humans and fast and efficient for computers. Not as fast as these, but, you know, a good sweet spot. Things like Python, just fun for you to write. They are fast. So let's be clear. You might look at this and think Python or JavaScript is very, very slow. You will likely not notice this in anything that you are writing. to be honest. You probably won't notice it. Computers are very fast nowadays. Processing is cheap, and you will not notice the speed of these things. In fact, Go will actually seem like it's taking longer for most things for you, because when you run it, it must compile first, and it's doing some weird stuff to make it happen, or to make it appear like it's being interpreted. But yes, these are a lot slower in comparison. When you actually get into the benchmarking and really determining the performance of an application, these are a lot slower. They're a lot slower, but they're a lot more fun to write. Ruby's fun to write. I think Python's fun to write. Perl, I don't think it's fun to write. I think JavaScript is very fun to write. To be honest, I hate it. I used to hate JavaScript. I now actually like JavaScript a lot, but Go is for sure my favorite language. And again, I love Go so much because I think Go taught me all the rules that I didn't know before, and it made me a better developer in all languages, to be 100% honest. So just there's a good little chart to kind of take a look at if you want to figure out what languages you might want to learn. There are a million other languages you could check out, but this is, just some of the popular ones. Here's one of them. You can click on that. I'm not going to click on this right now. It just kind of goes into some comparison and some pros and cons of different languages. So hop into the slides if you want and grab that link. We're not going to go over that right now. Now, with the time that we have left, we're going to talk about the more fun stuff, okay? We're going to talk about how do you even write code. But before we do that, I do want to talk about one thing I didn't put in here. I do want to talk about the Dunning-Kruger effect really quick, because we brought it up before, and I want to make sure we talk about this, because we just talked about a lot of stuff, and I flew through it. I did not spend a lot of time. We talked about compilers and data types and integers and Booleans and a bunch of stuff. Some of you are probably super overwhelmed right now. It's okay. It's okay. The reason why we are kind of just flowing through these things is because we are going to spend time specifically on just about all of these things. If we go in here, look, we learned a little bit about data types and stuff right now. We will spend a significant amount of time in each of these sections seeing and saying all about strings. We will spend an entire week talking about a singular data type, and then we'll start talking about numbers, so floats and integers and all that stuff. We will talk about all these things. We'll get in depth with all of these things, so don't sweat it. Don't worry about it. But this is what we have to talk about. Open image in a new tab, the Dunning-Kruger effect. I talk about it as much as I can because it is real. It is important for you to know about. This is the effect that is directly responsible for a lot of burnout, not a lot of burnout, a lot of imposter syndrome, but this is how it works. Check out the axis to the left. This is the confidence axis. Check out the experience axis at the bottom. This is for experience. As you start something, you're starting right here at the 0%. You have no confidence in this thing and you have no experience. Sounds like a good place to start. You start learning something. You get a tiny bit of experience as you start moving to the right. All right, you get a tiny bit of experience and you're like, cool, oh, I can make this thing work. I see how that thing works. You don't have a lot of insight into it yet, but your confidence goes through the roof. It goes all the way up because you're learning the thing. You're like, oh, I can do this. Like I understand that. I'm making things happen. Your confidence goes way up. Then you get a little bit more, experience. And so people call this right here, they call this Mount Stupid, right here, the top of the mountain. I don't like to call it Mount Stupid, but it is, that's what it's called. That's what it's affectionately called in the industry, Mount Stupid. And you quickly fall off of Mount Stupid, where you believe you know so much and you're very confident. And what happens is, as you get more experience, you start to learn about all of the things that you don't know. And you start to learn that there's a big, there's a huge difference in the things that you do know to all the things that exists for this topic. And this could exist for anything. This could happen for anything you're trying to learn. And then you drop off of Mount Stupid into the Valley of Despair. Okay, that's what this is right here. So take a look at this. You have so much more experience right here in the Valley of Despair than you do over here, but you are much less confident. You know way more when you're right here. You know way more than you knew back here, but you don't feel that way. You are not confident because you know the full extent of what there is to learn, and you've run into issues. You've seen the things. You've seen some things. Okay. And so then as you start to get more experience, it goes back up and you become more confident in things. This is where people quit, right here on the way down. People always quit on the way down. Okay. They quit on the fall. because, you know, you're still getting more experience and you're still getting less and less confident in what you're doing. It is, it's important to know that this exists. It's important to kind of see how it's charted out here. It's important to know where Mount Stupid is. It's important to know where the Valley of Despair is. So you can, throughout the entire life cycle of your learning experience, figure out where you are personally, and make sure that, you know, you're doing the things necessary to keep you from quitting during these times. You won't always experience this, but you will experience it a lot. It's natural. So just, you know, make sure that when you're on, as you start to get really confident, you know, just understand, feel that confidence. I want you to feel that confidence and feel how good you feel when you're confident about something. But I want you to be cognizant of like, hey, you know, I'm gonna get to some things that I don't know. I'm gonna get to some things that are tough for me, probably pretty soon. Okay, so just, you know, it'll help you not fall off so far. Maybe you could throw yourself, you know, maybe you'll have a parachute, you'll go prepared with the parachute, so, you know, maybe it'll be more shallow, maybe you'll you know, only go down to here or something like that. You know, maybe we can, the reason why we're now using a surface, maybe we can do something like this. We can, you know, you can instead make your line look a little more like this. Oh, fancy, isn't it? Okay, maybe you can do that. That's the goal. You know, we want to flatten that as much as possible as we go on and on. Perfect. Do not be seriously, don't be afraid for realizing you're up here on Mount Stupid. Don't be afraid to say it. Don't be like, it's okay, talk about these things. That's one of the biggest things in the tech industry that I really am hoping becomes normalized, is talking about like how much you're struggling with something, and how much something doesn't make sense to you, and how much, you know, it's okay to talk about these things. We're all struggling with these things. We've all been there. So know about the Dunning-Kruger effect, understand that you will get to a point where you're confident, and then quickly to a point where you're not. So just be wary of it. And the last thing is just, how do you write code? Where do you write code? What do you use to write code? And we use text editors, or integrated development environments. These are also just text editors. We will dive into the intricacies of both. There are a bunch of options out there. The one that I recommend is VS Code. I think you can type in VS Code, and I think it'll give you maybe, no, it does not. I really thought that was a command. Hold on. Let me see. VS Code. Did I do a bunch of different ones? I don't know. In my commands, I thought I gave a bunch of ones. That's the one that I recommend. VS Code or Visual Studio Code. This is a text editor made by Microsoft, not to be confused with Visual Studio. So Microsoft has, you know, their own coding frameworks, .NET, all that stuff. Visual Studio was their editor designed for all that. Visual Studio Code is a newcomer to the game. Visual Studio Code took, you know, it came out and it took the industry by storm. It is an open source text editor. This means that the code for it is the source code that makes up this application is available. You can see it, you can read it, you can contribute to it. If you want to make a change to Visual Studio Code, you can actually go in and submit a change to it. It's available on every platform. This is the best. It's like, it's the best. I can't even, you know, I can't say much else about it. I believe this is the best editor out there all around. The ease of use, the interface, the speed of it, and it's very hard for me to recommend any other. Like, if you got to recommend one, this is the one that I think you have to recommend to people, especially newcomers to the game. So if you go to code.visualstudio.com, it will give you the executable for your machine, and it's pretty easy to install. And so let's add a command really quick. So what's this? Command add. Again, remember I told you guys I'm a terrible typist. I'm being a terrible typist right now. But now if you hit exclamation point VS Code, it will give you the link to VS Code. I don't know why it took me so long to do this, but like I said, really great. I think I already have it installed on here, and this is what it looks like. Nice little interface where you can open up your files over here on the left, and then your files open up on the right. So text editor is just an application that edits text. So think like Microsoft Word or something like that, except this is not a rich text document. This is, you know, it's designed to work with programming languages. So it gives you some really cool things like syntax highlighting. So it changes the color of things so that you can visually understand and see what different things are. It has support for all kinds of different things, all kinds of different languages. It's really extensible. That's one of the reasons why people love VS Code so much. You can add extensions for just about anything, and you can tailor the experience to whatever you want. But it's also a great product right out of the box. I've done 0 modifications to this VS Code right here. This is brand new. But yeah, extensions are definitely the reason VS Code took everything by storm. VS Code really did hop onto the market, and it became incredibly popular very quickly, because there's a lot of Microsoft haters out there, and I get it. I'll tell you right now, as someone who was full Linux all the time for a very long time, I get it. But this is a good product for sure. Before that, people were using things like Sublime. Sublime was a really good text editor. Really good, very fast, not as easy to use. Still a good text editor. It's a freemium model, so it is free, but every time you save it, like every third time you save it, it'll be like, hey, maybe you should consider buying a license. I do own a license. I have no idea which email it's in. Bought it years ago, but it's a good editor for sure. It works for some people. I know people who still use it every day. Atom is another editor made by GitHub. I used to never talk about this because it was terrible. It was very slow. It looked good, but it was very slow. It's become much better. I think it's a pretty good thing. It's kind of weird because Visual Studio Code is owned and created by Microsoft. Then Microsoft went out and bought GitHub, and GitHub, is the creator of this. So they're now, holding and maintaining 2 different text editors. But Atom's cool as well. If you want to check it out, check it out. There's a bunch of other text editors, a bunch of them. There's another one called Vim, which is one that's inside your terminal. I prefer Vim to VS Code, but I've actually moved back into VS Code for you all with Vim key bindings. But yeah, we'll talk about all those things in depth a little bit more later. But VS Code is the one that I recommend. Simply click it, download it, install it like any other application, and you might be ready to go. Okay, it's pretty dope. This is what I'm going to be using because I fully expect it's what most of you are going to be using. And I'll show you how to modify it a bit to make you, make it look good, try out some new themes, make it feel at home, because it's pretty important. You got to look good to perform well and to feel good, all that other stuff. So I'll give you guys some extensions and things as we go along that will make it better for you. Now, here's what we're going to do. We are going to need, in this course, all you're going to need is a text editor. Okay, it's a text editor and 2 runtimes. So you're gonna need 2 applications, both Go and Python. They're programming runtimes that you're gonna need to download and install onto your machine. Okay, I'm gonna show you how to do this. Here's where where virtual learning like this gets pretty complicated. Okay, you have basically 3 options, 3 realistic options for a desktop computing environment. Your operating system that you're probably looking at is either Mac OS, Windows, or Linux, most likely. Yeah, you might be looking at this from an iPad or a phone or something, but when you're doing the coding, you're probably going to be from one of those 3 operating systems. All 3 are built differently. Both Mac and Linux are Unix like operating systems. That's not super important to know right now, but those 2 are more alike than different, to be honest. They're pretty close to each other, and a lot of the things that you need are already there or have been specifically built for systems like that. Okay, Microsoft is built differently. It has its own kernel that is much different from a Unix or a Linux kernel. And so the engine that runs it is a little bit different. So generally it's a little harder to install development tools on a Windows machine. I don't even say harder. It's different. So that makes, when we're trying to install stuff, when we're trying to figure out what to do, it makes things weird. Now, Windows does absolutely, Doc Jones. Windows Linux is so important. People always ask me if they should learn Linux. Linux is so important that Windows now ships with a included Linux kernel inside of it. Okay, it can be part of the system. This is called the Windows subsystem for Linux. It is that important. And so now there's a lot of parity amongst operating systems. But what this means is there's still a little nuance and differences between the way you do things. I don't know the full extent to you all's computer knowledge. If you're someone who's diving into this, who you can absolutely be an amazing developer and not know much about getting around your computer. 100%. Let me be very clear about that. You do not need to be good with computers to be a good programmer. Not even close. I know so many of them. But if you're someone who's been using Windows your whole life and you're used to installing things via Windows, that's fine. You can do that. Both Python and Go run fine on Windows. The problem is that I will be, when we are doing certain things, I'm going to be running from a Linux base. And so there's going to be times when I'm doing commands that you may not be able to follow along with if you install this directly in Windows, okay? Because the Windows operating system is different. So I'll show you right now. If I am in command prompt on Windows, this is the terminal in which we use in Windows to kind of get around. For me to be able to see what is in this directory, I can't just type ls. You don't even know what that is right now. I've typed in things like dir to see these things. But if I am in Linux, so I have both of them, again, remember, actually, I think ls works in PowerShell. So that's interesting. Now that's, a whole new level of things, but you can see here that all these things are working differently. There's different commands to different things. This is Linux right here. There's a little penguin right here. I'm using the Windows subsystem. Windows works a little bit differently. The way that file paths work is different. It's okay. Yes, you can absolutely use a VM if you know how to use a VM. All right, 100%. Use a VM if you know how to use a VM already. I encourage you to use a VM if you understand how to do it. I also encourage Ubuntu or any kind of Debian-based distribution, specifically Ubuntu, Pop OS. I is what I recommend. But that's a lot of extra stuff. I do want to make this as easy as possible. So the option for this year, and this is what I'm going to show you right now, is you can install everything locally. If you understand how to do that, or if you think you're comfortable enough with your computer to install everything locally, do that. Pretty much everyone who's on a Mac, you'll probably be completely fine. If you're on Windows and you understand how to go through and install WSL and set WSL up, you're fine. You can follow along with me perfectly. This is almost exclusively for the Windows users who don't feel comfortable enough to install WSL or hop into it or anything like that. Yes, Homebrew is super helpful. For everyone else, or anyone who just wants to follow along exactly how I do things, because I'm not going to be installing the stuff locally. This is one of the reasons why if you look below, you'll see there is a banner for Linode for $100 Linode credit. Linode it's a VPS provider. They're a cloud service provider. You get $100 worth of credits. No credit card required. Okay. A server costs $5 a month. So what are we? 2 months? 2 months? It's gonna cost you $10. The reason why we partner with them was specifically for this, to give people a way to do things exactly how we do them. And so I'm going to show you how to set that up really quick in case you want to get your own little computer. What a Linode server is, it literally is a computer, a network computer, a computer that you can connect to, that you can do some stuff with. So this is what you should be doing during this time right now. Either if you're on Windows and you want to learn how to do everything locally, I highly recommend. So 2 things. Actually, I'm gonna give you another caveat. If you're on Windows and you understand the concept of file paths, and you believe that you have a good understanding of file pathing, and you think that when I'm going through stuff in Linux, you can understand how to properly get to where you need to be in Windows, feel free to do it there. 100%. You're free to do that. Everyone who's using a Mac, you're likely fine. Yeah, pretty much just the pure Windows users. to be 100% honest. Or spend this time to try to get WSL set up. You do have to restart your computer to install WSL. If your computer cannot get WSL2 installed, I actually recommend that you do the method that I'm going to show you now. WSL2 is in the second. The Windows subsystem for Linux is in its second iteration. 2 is much better than 1. There's a lot of benefits to it. 1 will work, but if your computer can't do 2, there's a number of reasons why I wouldn't be able to do 2. I recommend just doing this on a server, to be honest. But I actually have an article coming out soon about why my new flow is to do things on a development server, a remote development server. I work on a lot of different computers, and I actually fully prefer to do that. So I'm gonna log into one really quick. New computer. I don't have any keys, but whatever. All right, so I'm all the way right now in a completely different computer. I'm in a server right now, and you know, you might look at this and say, oh, that's weird. I don't like this. Like, I don't want to do that. You might not have any command line experience. I didn't say this was a prerequisite. So yeah, so this might be pretty confusing to you. You would not do your work in here. I would do my work in here because I'm comfortable with it. I could go into, you know, I got some stuff going on. We were learning Rust a little bit, and you know, we wrote a little FizzBuzz Rust, and I might look at it like this, and I might do, oh, what happened? And I might look at all my code and say, you know, and just operate out of here. This is not for everyone. Don't do this. I'm not looking to confuse you at all. But there are a lot of cool things you can do. But what I am looking to do is to connect to this server through VS Code. VS Code has a lot of cool things in it that allow you to do this. So this is what we're gonna do. First, I'm gonna go to linode.com, or you can click that link below if you want to do this. Again, I highly recommend using it regardless, because you can play around with all the stuff with no credit card required, and you know, you can just do that stuff. So linode.com, I think /mastermind.io will give you the credits or whatever, but you simply sign in like anything else, make an account, pretty easy to use. I'm gonna log in really quick, and all we're gonna do is when you are in here, we are going to spin up a VPS, a virtual private server, our own little piece of computer. We're basically going to be renting computer space from Linode. Remember, we talked about that computer hardware, that we talked about RAM, we talked about CPU, we talked about hard drive space, or hard disks. You are basically you're paying Linode to borrow some of their CPU processing power and some of their RAM and some of their hard drive space. Now, again, you get $100 free. The cheapest ones are $5 a month. You can get bigger ones if you need. The $5 one will more than do. You can see I have a bunch of them here. To get a new one, you simply do this. Oh, it says a credit card is required. I didn't think a credit card was required. I don't think I put a credit card in. I'm pretty sure. If it is, I'm sorry about that. You have to put one in. You can try to use one of the other options. I really am not trying to get you to pay anything. The goal is I wanted to give people one good way so that we can follow along together. I tried to do this originally with Linux, with VMs. Yeah, that doesn't work because everyone's computer isn't powerful enough to run VMs. Some people are having trouble figuring out how to enable virtualization in their BIOS. There are a lot of options. There's tons of options. So yeah, so if Linode asks for a credit card, I'm trying to think of what other options there are. I think everything requires one. If you use DigitalOcean, if you use Amazon, there are a bunch of other ones to do it with. Like I said, this one is just for, it's because they'll give you credits for it. But yeah, once you're in there, one caveat is that I'll be using NVIM. Go for it. Definitely go for it. I'm currently working on getting my full dev environment in a Docker container. Ooh, I like that. That's very interesting. I like that. So I thought about doing that a couple times. And then I did not. Definitely did not. Heroku doesn't require a credit card. So does Heroku have, yeah, I mean, that could work. I don't know if, can you just SSH into, I don't know anything about Heroku, to be honest with you. Cloud platform, a cloud application platform. Yeah, if Heroku gives you something that you can SSH into, this will work. So essentially what we are about to do is we are going to create ourselves a little environment up in the cloud. And then we are going to connect. We're going to connect our VS Code. We're going to create what's called an SSH tunnel into that environment, just so whenever we open up our VS Code, we can log into it and we'll be doing all of our work locally on our computer, but everything will be running up on that machine in the cloud. So yeah, I mean, that's what we're setting up. And again, this is only an option for anyone who wants to follow along exactly how I'm doing things. That is something that people have asked of me in the past, but I cannot work off of 3 operating systems all at once. People are using all kinds of different things. So yeah, you know, if Heroku does that and you can do it for free, 100% do that. Just make sure that you can SSH into it. That's all that matters. Okay. What's up, DJ Mathman? How are you doing today? I'm doing good. Can't complain at all. So really quick, this takes almost no time to do. We're going to create a new Linode. We're going to create a new little server. And so I click the create button. Distributions, you can choose whatever you want, but we are going to choose Ubuntu. The latest one of your choice. The latest one will probably be fine. Let's choose the 20.04 LTS. And I'm actually going to give you all a little, I'm going to do this really fast now. Don't sweat it if you can't go through this now. If you're trying to figure out if this is the option for you, if you want to try out some other methods that we talked about, I'm going to submit a Notion page to you all with instructions on how to do just about all of these things, all the options, if you want to try some of those things. Okay. So feel free to try those first before doing this. You will have the instructions on getting this done after this is over. So don't sweat it. I got you back. You know, it's okay. I'm just going through it for you now so you have something to reference if you ever want to go back and look at it afterwards. You don't need to get this done right now. One of the assignments is to take care of this and get this all set up later. Really, you only need this for next week. You don't really actually need any of this set up for this week. Even though we are going to be writing code, you'll be okay for sure. All right, so I'm gonna click 20.04, select your region, pick the place that's closest to you. This is gonna create this in a data center that's in the location that you choose. The closest one to me is Newark, New Jersey. Just choose the cheapest one here, which is gonna be this top one. It's gonna give us, 1 GB of RAM, 2 CPUs. I'm actually gonna choose the 2 gig one, to be honest. That's $10 a month, so you can do 10 months of this if you do decide to use this. Yes, the video will be available after the stream. It'll be here on Twitch for 14 days. It'll be up on YouTube 24 hours later. Yesterday's video is going live right after this stream is done. But yeah, it'll be up 24 hours later. So I'll just choose this. You can give it a name if you want. I'm gonna call this deCoded sandbox. Cool, deCoded sandbox. Whatever, you can do whatever you want. This is the most important part right here. Don't mess this part up. I mean, you can always just create another one. You can destroy this anytime you want. But root password. So make yourself a password that you can remember. And this is the password that you're going to use to log in. I made a fair password. Not a big deal. If you guys hack this, not a big deal. Fair password. Don't worry about SSH keys unless you know what they are. Absolutely go for it if you know what it is. Don't sweat it if not. And then just click create. So basically all you're going to be doing is selecting a few options, Ubuntu, and where it's located, select which plan you want, and then give it a name if you want to, and then select a password. Okay. And then click create. All right. Thanks. See you later. Absolutely. I'm doing my best. But yeah. Also, I missed something here. You got sponged. Sponge. Thank you so much for the Twitch Prime sub, or just a Twitch tier 1 sub. I appreciate it. Thank you for the support. Same thing to Think 2020. Thank you so much for the Twitch Prime sub. Thank you for the love. Thank you for the support. Hope to see you back. All right, so we created this thing. Now, gives you a bunch of stuff here on this page. Now you all know my IP address and stuff. IP address is where this server is, how you access the server. It is the location in which the server resides. This right here, access. This is the command that you want right here. Okay. This SSH access key command is what you want to copy. All right. You can always get back to this in the, if you click on Linodes and click on your Linode, it'll give you this SSH command. This is the command used. This is how you access Linux computers remotely over a network. Don't worry about it. I'm telling you, just Right now, you don't have to remember that command or anything like that. Here's what we're gonna do. This is a server, it's up and running. I can log into it if I want. So the same way I logged into this, if I paste this into my command line, and then it's gonna ask me for my password, maybe. If it's up yet, it might still be provisioning. Oh, now it's running. It just moved to running. So let me try that again. It might take a few minutes to get fully provisioned. I'm being a little mean here. I'm trying to make it go faster. My referral code, it's underneath my Twitch stream. I don't know what it is. If it's actually, I don't know if it's still active or not, to be honest. I assume it's still active. I keep it there for anyone who wants to do anything. Should still be active. But it's underneath. Let me give you the exact thing if I can. I should know it. It's got to be /mastermind.io. It's got it right. It has to be. Yeah, there we go. I guess it's just, I don't know what this is, but I will share it just in case. There we go. I'm with it. So let's see. Let's try to log in now. You don't need to log in. I'm just showing you that this will allow me. It says, I have to type in yes. Basically saying, hey, this is the first time you're logging in. Do you want to log in? And it's going to ask me for my password. I'm going to type in my password and type it in. It's not going to show you typing it, and it should let me in. I don't like that it's not going past this point, but it should let you in. You don't need to do this at all. I'm just kind of just showing you that I could log into it. Gives me a little welcome message, and now you can see that my little prompt here is different. And that's your best indication though that you're in a different computer. But that's not what we're gonna be doing. Don't worry about that. What you're gonna do is you're gonna hop into your Visual Studio Code. And what we're gonna do is we're gonna install an extension called Remote SSH. So just hit the little panel right here for extensions and simply type SSH. It will be the very first option that comes up. It's people love it. Look at it. Over 2 million downloads, 2.5 million downloads, and it's got almost 5 stars. It is really good. All you got to do to install it, click that little install button. Phenomenal. Very, very exciting. It's installed. We didn't even get a bunch of prompts or anything. It's just there. All right, it's just there, and we're ready to go. Okay, so now that that's installed, you might have been like, oh, did it install? I'm not even sure because it happened so fast. Great. It is now installed and ready for us to use. This is how you use it. All you got to do is set it up one time, and then every time you log in, you can easily connect to the instance that you want to connect to. Master Dark Weaver, thank you so much for the follow. Oh, it's Jose. Welcome. Thank you for the follow. Let's see who else I missed. Casa Dokon Hijos, welcome to the channel. Thank you for the follow. I'm sure I missed a ton of other people. I promise you, I was not purposely trying to miss you. Just trying to keep us on a relatively reasonable time scale. We're almost done here. I appreciate that. Oh yeah, be more fun. 100%. For sure. Absolutely. I've hung out in there a couple times now. 100%. I appreciate that. Definitely appreciate that. It's good to see you, Toronto's TV. I appreciate it. All right, so all you got to do once it's installed, so yours won't have this little file here or whatever. All you're going to do is you are going to hit Control P. It might be Command P on a Mac. You're gonna hit Control P, okay? It's gonna open up a little search command window thing. It's a really good place to be. There's probably an easy way to do this, but I don't know what it is. Then you're gonna do a little greater than symbol, okay? And this is gonna allow us to kind of search for something. And I'm gonna type in SSH. So SSH, if you want something to help you remember what it is, it stands for Secure Shell. And it's just a secure, it creates access to a secure shell in a computer for you. And so all you got to do, you only have to do this once, is click this Add New SSH Host button. All right. And what this does is this is going to allow you to set up the server that you just created so that you can easily log into. And when you click that, take a look at this. It says, hey, please enter your input message. And it gives you an example. It looks just like what we just copied from Linode. Oh, whoops, that's not what we want. Let me turn on history. So if you didn't copy it, let me go back to what Linode gave us. Just remember to copy that SSH access that Linode gave us right here. Paste it right here. Make sure there's no space or whatever. All right, so we'll break this down a little bit, but SSH is just the command to log in. Root is actually the user in which you are going to be logging in as. And then this is your IP address of the location of the server. Not super important right now. We'll dive deeper into it. But you just hit enter and it will take you to another thing and say, hey, I want to know where to save this stuff. Just hit enter again. Don't sweat it. You don't need to worry about this right now. Just go ahead and hit enter again. And once you do that, it'll give you something in the corner. So just paste it, hit enter twice. It'll say, hey, host is now added. Go ahead and connect. So when I click connect, nothing's gonna happen because I think I missed the connect button. If you missed the connect button, like I just missed the connect button, just go ahead and hit Control P again. Do your little greater than symbol. Type in SSH again and click connect to host. If you ever need to get back to here, just remember greater than SSH and it'll give you all the options that you need. I'm gonna click connect to host. This is the one that's gonna connect you to something and it's gonna bring up your options. So this is the one that I just put. This is just the IP address, but this is the only one that I have in here. You click on it, it's gonna open up a new window. The very first time you open up to it, it's gonna ask you for some setup. This is a Linux system, so go ahead and click Linux. It's gonna say, hey, are you sure you wanna continue? You have to either, I think you have to type in yes, or maybe I was just supposed to hit continue, or just hit enter to continue, and then it'll ask you for your password, okay? So go ahead and type in that master root password you put in there. And when you type it, it'll take a little second. It'll give you this thing down in the corner. And then now we are done. We are in. Okay. How do we know that we're in? We know that we're in because it'll give you this little connection prompt over here, editing on SSH. And now, as far as you're concerned, you don't know, you're working off your own computer, but you're executing everything on this system. Now, every time I leave and I come back, let's say I want to go back into VS Code. By default, if I just left that, it's going to try to connect again. It's going to ask me for my password. I'll just put my password in. You never have to run that setup again. And it will get us all logged in. Ubuntu plus WSL does not interfere with my Windows 10 OS at all. Does it? No, it does not. Ubuntu plus WSL does not interfere with your Windows 10 OS at all. You can interact with them if you want, but it doesn't mess with it at all. Yeah, it's very unlikely. Like I said, you can do some stuff, but it's hard to do it. It's hard to. They're pretty separated. All right, so I'm in the system. So actually, if I were to, there's a terminal in here, and I could. I forgot. If I look at my IP address and stuff, I can kind of confirm that I'm not on my own computer. If I type in something like host name, that was dumb, localhost. But yeah, I'm actually operating out of this system. So once you set it up, you're kind of good to go. Then, through the entirety of this course, I'm going to be operating just like this, and you will be able to do everything that I do. You'll be able to, every command I enter, everything that I type in, you'll be able to follow along exactly. You don't have to do anything different. For everyone else, there's going to be some slight differences. I will try to explain those as we get to them. You'll kind of understand it. We're going to go over file pathing and all the other problems that you might come into contact with. Besides that, all the commands on Linux and Mac are essentially the same. There are some variations. There are some variations in a few of the commands, grep being one of them, a very popular command, not super important. We're not going to use it at all in this course. We're not going to do a lot of command line. We're not going to do almost any command line stuff. I'm going to teach you the basics of it, but we're going to be writing code and learning how to run it. But you are going to be running the code most of the time from the command line. So basically, that's all you're going to learn is how to move around a little bit and how to run the code there. Now, what's nice about Linux is if we want to install Go or if we want to install Python really quick, Python's already installed. It's it's not installed. Wait, no, it might be installed. Okay. Whoa. What? Okay. So Python is already installed. It should already be installed if you did it this way. Go is not installed. and we can quickly go ahead and install that. And the way that we install that is, first we need to run this command right here, which is going to update all of our packages really quick. And I'll share this again. I'll definitely share this, but run sudo apt update. This is the first thing you need to run. I'll share this in here. And it's okay, I'm installing these runtimes now. Again, you have a week to do this, and I've provided you, there's an assignment to do this, and it will have all the instructions for doing it later if you're having a little bit of trouble. I just want you to kind of see it the first time I'm running it kind of live here to see that it's a pretty simple process. Manually, we could manually install these things, but we don't need to. The way that we install Go is sudo apt install. I think it's just Golang. That feels right. And I'll share that with you. And so this is Linux that I'm running all these commands on Linux on that Linode server that I just spun up. And that's how easily you can install stuff here. You gotta learn the command, but it is pretty simple to do. And just like that, it'll go through, it'll install the stuff for us. We don't have to do anything special. You'll probably feel like you're in the Matrix, which is great. You'll feel cool. You get some instant feedback because it's doing all this cool stuff. But we don't have to do anything else, and they'll both be installed. I'll show you that it's installed. And this is just to show you the point that you can get to in the next week so that we can go through something else. So good question. Apt is a package manager. It stands for Advanced Package Tool. Yeah, it stands for Advanced Package Tool. It is a package manager. So if you're familiar, if anyone is familiar with Homebrew, Apt is Homebrew for Linux, or for Debian. For Ubuntu, it is the same thing as Homebrew, and it manages packages. It makes it easy for you to install applications. That's all it does. It's like the App Store. It's really like the App Store. So it makes it easy for you to install some stuff. That's all it is. Yeah, it is like NPM. It really is like NPM. NPM is a package manager for Node. 100%. You got it. Raul5660, thank you so much for the Twitch Prime sub. Tobias as well, thank you so much for the Twitch Prime sub. Thank you so much for the love and the support. Thank you for deeming me worthy of receiving your only Twitch Prime sub for the month. I do appreciate it. What's up, Nate? I got it this time. Remember, I kept saying not 10 lift 151. I got it. It has been a while. It's good to see you. Welcome. See, I don't forget the face of a name. When and why did I decide to get into tech? Great. That's a good question. Why this is still downloading. So I decided I was always into computers. We had a family computer. I begged for a computer kind of going into middle school or high school for the new family computer. I was really the only one who really used the computer. But I'm not someone who's been programming since I was 14. That's not me. I, on the other hand, was illegally downloading music and trying to burn CDs, doing things that a young boy probably shouldn't be doing. I probably looked up some things that I shouldn't have been looking up, just using the computers for fun, getting on the internet, it's exciting. So I did that for a little while. And then, I was really interested. I've always been interested in electronics. So actually, when I went to school, I actually wanted to do mechanical engineering, actually. Again, told you all I'm into motorsports. I love cars. I really love anything that moves. I love bikes. I'm really into bikes as well. I'm really good with my hands. I really like building things. I sat in the session from the mechanical engineering program, and it was not what I thought it was. It really was. I didn't know at the time. That thing really set me off. So I was trying to figure out what else to do. Like computers, decided I want to do computer science. I got weeded out of that real fast, to be 100% honest with you. Bike as in bicycle. I love motorcycles. I was into motorcycles for a while. I never, due to my family never giving me the green light, I'm sure my wife would be extremely angry if I ever got a motorcycle. I love motorcycles. I've ridden them, even though I shouldn't have ridden them, but I never had a motorcycle. But I do like them. But I got into that. I got weeded out of computer science, ended up doing information systems, ended up, just started out in help desk. Let me be clear with you all, and honest, I never finished school. I did go to school. I was on scholarship for track and field. I went to school. I went to school for 4.5 years, and I never finished. Mostly because I ended up getting a job in tech that was far away. And you keep telling yourself, oh, well, yeah, I'm gonna go to class, and I would get off and have to fight 2 hours of traffic, and I wouldn't go to class. And so I actually never finished. So if you're someone without a degree, I promise you, you do not need a degree to get into tech at all. Almost like, yes, there are still companies that care about it, but a vast majority of them don't. The skills are what matter. So let's be very clear about that. I am a half self-taught guru. I would say half self-taught. I've been shown the way by a lot of people. I'm gonna be honest with you, I learned almost nothing in school about systems administration or coding, to be honest. Like, the classes were kind of BS. They weren't good. But when I was at these places, I did get in good with people who kind of showed me the ropes and showed me different stuff. Like I said, I started out in help desk. I moved into systems administration because a systems administrator there, we became good friends, and he started showing me some stuff. They would be working on some things, and he would be like, hey, you want to check out this? This is how we do this over here. And that was pretty dope. So like, I was shown the ropes at a lot of places. And I just kind of, started to ascend the ladder, and I started to explore my own new things. And yeah, I am self-taught in a lot of areas, a whole lot of areas, to be honest. I do enjoy learning new things, but that's how I got into tech. And then I got into the place where I chased the money a little bit. That was good until it was bad. If you're someone who is chasing the money, which it's okay to chase the money, it's okay to be in tech for the money. Don't let anyone tell you otherwise. Everyone thinks you got to be all righteous. No. We're doing this. Yes, it can be interesting. It can be a passion of yours. You can like the challenge. You can love solving problems, but these are for jobs. These are to take care of yourselves and your family, to help you live the life that you want to live. It is okay to want money. It is okay to talk about money. 100%. It's okay if that is your motive. 100% okay. But I will tell you that chasing the money will eventually get you into a place that you don't want to be in. You can get out of it. 100% love to get out of it, but it will likely get you into a place where you don't want to be. You'll likely leave somewhere that is great for you to go to somewhere that is terrible for you for an increase in pay that is not really worth it. And you'll get to a point where that matters, where that's okay. Now, that point is different for a lot of people. Okay. I will put up with a lot of crap for enough money to take care of my family, but once you're past that point, once you're past your needs, and you're chasing it for your wants, you're going to run into a problem. I mean, my problem was at a point when I told a guy I was going to punch him in the face, and I walked out. It got that bad where I was like, hey man, I'm a nice guy, but I'm going to punch you. So I'm going to leave now. And I went to the auto show. I went to the Washington Auto Show because it was the midday, nobody there, really nice. And luckily I had a job within the week. That is what tech can do for you. Don't do that. Don't follow my footsteps. Please do as I say, not as I do. I was a lot younger at the time. I had almost no responsibilities when I did that. But I don't know, there are a lot of opportunities in tech. I want to be very there are so many unfilled roles. Companies are struggling to find talent. They really are. There's a reason why the salaries are so high. These skills are in demand. People aren't staying at jobs for long. It's hard for people to retain talent. I can't tell you, I've not gotten roles. I've been passed up for a role and then got called 2 months later because the person they chose already left. And I've taken the job before because of that. So there's a lot of different ways to kind of go about it. We'll push you into code. Push you into code is that's where the industry was going. That's where the money was going. I kept diving back into learning how to code because it was harder and harder to find good sysadmin jobs, to be honest with you. Like I had gotten to a ceiling for my area. It depends on where you live in the country. I had gotten to a ceiling of sysadmin roles, to be 100% honest. It was, to be quite honest with you, I was at the point where I was getting paid like $110, $115 for sysadmin jobs. And I found a few that were more, there are absolutely sysadmin roles that'll pay more than that. But I was having there weren't many of them. Like I could get 1 million of them that paid $115. I had a lot of trouble going farther. And so I saw, DevOps was a thing. I saw that software was eating the world. So I started to dive back into that stuff. Software is one of the hardest things it's one of the harder things to learn, because again, it's not immediately applicable. Like, you have to have a problem to solve before you can use it to do anything, or you have to have something you want to build. And it's kind of weird. You're gonna have to learn two pieces: the thing, and then how to use a thing to solve a problem. So it's a little bit different than all the other tangible things, like especially in systems administration. The rules are a little bit different, but it is the most valuable skill you can learn in the tech industry. I don't care what anybody says to you. Yes, your fastest path to a job, to me, is cloud and containers right now. That is my full recommendation for everyone. But I think that everybody in the tech industry needs to learn how to code. Network engineer, everything you need to learn how to code. It will make you better. And when you learn how to code, I'm telling you, it's wild. You can do anything. Like, it's great. Right now, I know that if I had an idea for a product or an application, I could take it from inception to product right now with my own two hands. I could do it on a little Surface Pro. I could write something that could make me millions and millions of dollars on a Surface Pro, and that makes me really excited. Like, having that power in your hands is super interesting. It's empowering. It really is empowering. And once you hop into it, it's fun. Is that, like, I have a good time doing it. Tech is not, I wouldn't say tech is my passion, or it wasn't my passion. But I think it definitely falls in line with my passions now. Like, I dive into a lot of the stuff because I love it, because again, you have so much power at your fingertips now. Like, so much power at your fingertips. If people only knew, if people, like, you'll find out you have so much power for sure. But yeah, that's kind of where my stuff was. Why did you leave your last job? No, that was the one where I was about to punch the guy in the face. That wasn't the last one. Oh yeah, why did you leave? Yeah. Oh, I was about to. Yeah, that's 100% what happened. So I decided to quit. That is really it. Also, like, come on. Also, it was one of those things where it wasn't because I really didn't want to punch the guy. You know, I'm not a violent guy at all. But I haven't been, exactly. I'm not a violent guy, so I hadn't been in a fight since I was, fighting my brother in, like, when I was really young. He was 6 years older than me, so he wasn't really fighting me. And I was like, what if I try to punch this guy and he dodges it because I'm slow, and then he punches me, or what if he kicks me? Huh? What am I gonna do? You ever been kicked in the face? I haven't been kicked in the face. I don't know how I'll react to getting kicked in the face. You can't be out here just throwing punches at people. Like, people are studying MMA and all this other stuff. That's where my mind was going, more so than, hey, I don't want to lose my job. It was like, man, I might try to punch this guy and he might kick me in the mouth. That is a real concern of mine. It's one of the biggest fears I have in my life. To be kicked in the face is wildly scary. Seriously, it's wildly scary. So, that's what happened. What was the VS Code process to connect to the remote host? I can SSH into it from the same computer, but not connect. Oh, okay. Yeah. So, the command to kind of get the SSH thing going, once you install the remote SSH extension. So remember, you just click the little extension button down here and type in SSH. You can click this remote SSH button. And once you do that, you hit Control P or Command P on a Mac, greater than sign, type in SSH and click add new SSH host. And then you paste the entire SSH command. Okay. You need the whole thing. You need SSH root at whatever. So you need to paste the whole thing in there, and that will set it up for you. I left my last job because my boss couldn't take my rounds kicked in the face. Yeah. I mean, I guess that would be badass. What do you mean with cloud containers is a similar cybersecurity? Oh, so I mean cloud and containers. So I think right now people always ask me, what is your recommended job path? And I think the best, setting where the barrier of entry is to the amount of money that you can make, to the amount of jobs there are, is, I think right now, cloud and containers. Right now, I think that learning in the cloud is relatively easy to do in comparison to learning how to code. In my own opinion, I could be completely wrong. I could be completely out of touch. This is just kind of what I've come to believe. But I think the cloud is so in demand. There are a million people. There are tons of coding boot camps. There are a lot of people trying to become web developers, trying to become software engineers. There are computer science programs at every major institution across the country. There are not cloud disciplines at all these organizations. There are not a lot of cloud boot camps, but it is something that is incredibly in demand. And so I really think cloud and containers is right now a good combination of the money that you can make versus how long it takes for you to learn these things personally. But yeah, cloud technologies and containers. So things like Amazon Web Services, things like Microsoft Azure or Google Cloud Platform, and things like Docker for sure. Wasn't support for Docker dropped? Yes, it was inside of Kubernetes. Not full Docker support, just inside of Kubernetes, and it didn't need it. Docker is just a container engine. Docker is still the most popular container engine for people to learn, and the concepts that you learn when learning Docker are applicable across the board for sure. Yeah, so you can learn all these things right here. Coding and software development are different. That's true. Cloud is easier than learning to code, which is easier than learning how to develop software. That is good. I like that. That is very good. And I am in full agreement, 100%. Coding and software development are absolutely different things. They really are. You use code to develop software, but yeah, I agree with you there. And coding is the easiest of them to, learning the cloud, because the cloud has more direct, tangible rules. It's more akin to what you're used to learning. There are, hey, this thing does this, and if you want to do this thing, do this. Coding works a little bit differently, but yeah. All right, so that is everything that we're going to go over tonight. Hopefully you got something out of that. Go back over the video if you need to. Again, tangible takeaways for the evening. What I want you to learn is that all we're doing when we are writing code is we are giving the computer instructions to perform a task automatically. That's all we're doing. It's nothing special. We're not performing magic. We're just giving instructions to the computer for it to be able to perform a task automatically. We learned a little bit about the different types of ways we do that. We learned that to be able to give the computer those instructions, we write something called source code. We learned that for that computers can't really understand that source code. It can't understand human readable code. It needs to be converted down into machine code. And so it does that through a couple different ways. One is through a compiler. This is a full translation of the code down into machine readable code or bytecode. We learned that bytecode is an intermediary format between the machine readable code and the source code that you write that is designed to be run on a virtual machine. Things like Java run on something called the JVM. We also learned that, that machine code is, ones and zeros, binary. And we learned that binary is really stands for two states. People like to show it as ones and zeros, but actually it's two states. It's actually a voltage passing through something or lack thereof. But it's a good way to represent it. There's a podcast that I linked in the Google Classroom that will tell you a little bit more about how binary works. We will dive into more about how binary works as well. We also learned about the different pieces of a computer. We learned about the central processing unit, the part that actually is doing the thinking, really, in the processing. We learned about the RAM, which is the random access memory. We learned that this is temporary, volatile memory. It's not permanent. It's designed to not be around for long. If you cut the power goes away. We learned about hard drives as well, and hard disk storage. That's permanent storage for your files and things. As some pieces of the computer. We learned about compiled languages that are translated beforehand. We also learned about interpreted languages that are kind of read line by line, and the interpreter decides what to do and translates that into machine code as it's reading through down the file. We learned some of the differences there where compiled languages are a little more efficient, a lot more efficient usually, because all of the processing is done up front. We learned that we can find errors a little bit quicker during compile time rather than runtime. But we learned that dynamic languages or interpreted languages have their benefits as well, because we can it's faster to run and test just because we can hop right back in without recompiling. We also learned that they have dynamic typing, which usually allows for a little bit more flexibility in what we're trying to do. And lastly, Basically, we just dove into some different text editors and things. We learned a little bit about data types, but we dove into some text editors, and we got a text editor installed, VS Code, which is my #1 recommendation, but feel free to try out as many as you want. There is a task in Google Classroom to try out as many as you want, and to, you know, talk about it, to have some feedback. A lot of what you're going to be doing in tech is learning how to speak about what you know. That's how you get a job. It's not about knowing the things that you know. It's about being able to prove to someone else that you know these things. And so you need to learn how to talk about them. So I do want you to hop into the Discord and talk to each other about these things and say, hey, I don't like this because of this. This is something that I don't like about VS Code. This is something that I love about VS Code. This is something that I hate about Sublime. Try some things out, have the conversations. Next time, we'll dive into a lot more stuff. We'll get even more set up. We'll dive deeper into the things that we learned tonight, and we'll start writing some code next time. And then we'll hit the ground super running next week, and we will be writing code pretty much nonstop until the end of the 8 weeks is up. So appreciate it, Blah. Thank you so much for the sub. I appreciate you coming through. You've been a big supporter of the channel forever, and don't think I haven't noticed. I appreciate it so much. Yes, no, so resource page link will be in Google Classroom. I will paste it in the resources section of Discord as well. So keep an eye out for that. If you were looking for, if you missed the stream from yesterday, that will be going live on YouTube very shortly. You should see it pop up very shortly. Come on back tomorrow for pipelines, where we'll be diving into, what are we doing tomorrow in pipelines? I don't know what we're doing tomorrow in pipelines. I can look at the list, but we'll be doing something cool in pipelines tomorrow, something exciting, and we'll really get going there. I think we're doing some more environment setup like we did today there, but it should be pretty fun. Are we doing Linux tomorrow? Perfect. I love Linux. It's my favorite. So I'm excited about that. Oh, 100%. We're definitely going to Fogo. Can't wait. Let me know. I'm here and I'm ready. But yes, I will. Everyone who, remember, you can contribute at academy.mastermind.io/contribute. If you reach those tiers, you will be receiving an email very soon with a type form to grab those things within the next day or two. So keep an eye out for that, and we'll get it out to you as soon as possible. But appreciate it. Who's online this evening? Who can we go over and say hello to? Is there anyone from the Only Dev channel on? Yes, Tej Dev is on. So we're gonna head over and say hello to Tej Dev. He does some really cool stuff. He's actually, what is he doing right now? Is he working on he's answering some common questions. He does some stuff with NeoVim, like he actually works on NeoVim. So we're gonna go over and raid him tonight, but definitely let him know we said hello. Let's see, he is part of the Only Dev team. That is one of the teams that I'm on. I love this team so much. But cool, everyone, thank you so much for another great day. I'm glad we're starting off the year right together. Keep the energy up. I will do my best to keep encouraging, to keep giving you resources. Reach out if you need anything. Reach out if you have any questions. Reach out to each other. Seriously, get to know each other. Reach out to each other, encourage each other, and let's do this thing. I'm excited. All right, everybody, have a great night in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Peace out, everybody. Have a good night.